I'll talk about this as a potential limitation in a few minutes. Overall, about half of the calls we received were for susceptibility testing, and then about 15 or 20% were for mixed IDs. So when a wound culture was reported out as mixed, asking for further identification, and then a decent number on special requests, as well as small numbers for result interpretation, result updates, and otherwise order guidance. When we looked at the overall action taken in the laboratory, there was a decrease in the no action taken, but an increase in the release of the existing data that was already existing within the EMR without a difference in additional testing being performed. Because susceptibility testing was such a major source of the calls that we received, we wanted to look specifically at some of the calls that we're receiving and design canned comments around that. When we looked at the data, we found reasonable numbers of call for Aerococcus, beta hemolytic streptococci, Candida glabrata, Enterococcus species, calls about E. coli, and additional susceptibility testing for those, some calls about Haemophilus influenza, as well as calls about Stenotrophomonas. And so we developed these canned comments to reflect that. So for Aerococcus, we say that they're routinely susceptible beta-lactams and vancomycin, and that in fact those are the recommended therapy. So once again, the statement that this is a recommended therapy is typically not something I would associate with the microbiology laboratory, but by working closely with our infectious disease pharmacy colleagues and having this run through a system-wide committee, we felt comfortable making that type of statement in the microbiology chart. Similar along the same lines for beta hemolytic strep, we say that what the treatments of choice are for these penicillin, ampicillin, first generation cephalosporins, and that resistance to these organisms has not been described. We do comment on the decreased susceptibility to fluconazole for Candida glabrata, and I'll touch on this in a couple of minutes. We did notice that we were actually getting a decent number of phone calls about drugs to which enterococci are intrinsically resistant, such as cephalosporins, clindamycin, and trimethoprim sulfa. So we did add this comment saying that these organisms are intrinsically resistant to these drugs. We reflexively add fosomycin on for some resistant E. coli in the urine. But we were actually getting a fair number of calls asking for this after we'd already set it up. So we went ahead and put a comment in saying that we were doing this along the lines of, tell people what you're doing and when you're doing it. We did get a small number of calls on Haemophilus influenza. So we added a comment on what the recommended therapy is for that, especially for amoxicillin and ampicillin resistant Haemophilus species. And finally, Stenotrophomonas is a bug that affects our hospitalized patients or ICU patients disproportionately. And so we were often getting calls about treatment options for Stenotrophomonas. So we added a comment describing how it's intrinsically resistant to most antibiotics, and that our first line testing is going to be for trimethoprim sulfa and minocycline, and that trimethoprim sulfa is the preferred treatment if susceptible and not contraindicated. When we look at the requests that were received during the pre-period and the post-period, we see that overall requests did decrease from 253 to 215, with decreases for both requests for panels as well as specific drugs. When we break things down by the particular organisms, there was not as much of an impact as we would have liked. And in fact, we saw an increase in calls about Candida glabrata in those cases. What's interesting to note, though, is, as I mentioned, we were getting calls about enterococci and drugs to which they're intrinsically resistant. Those actually entirely went away in the post period, and the calls we were getting were about different drugs. For Candida glabrata, I think there was generally not widespread awareness that there was. Along those lines, these pathways may have been used by attendings, fellows, residents, and hospitalists in different ways in different periods, leading to potential bias of the results that we're generating. It's also possible that the call log may have been less reliably used by different shifts across the day in the laboratory, leading to potentially different results. The 1 year gap between the pre and the post periods may contain or encompass changes in clinical guidelines that prompted different calls. And additionally, that gap may mean that different laboratory personnel were screening and responding to questions as residents and fellows turn over. When we look back at our data, some of the limitations of canned comments became clear again, which is that mixed cultures continue to be challenging. So that a mixed culture may describe very different clinical scenarios. Interpretation of mixed cultures can be more subjective. Additionally, resistant isolates may need to be excluded for therapy, prompting some of these calls. At the end of the day, we look at these plates more and talk to providers more. Canned comments are not patient specific, so that if the patient has allergies, renal impairment, or potentially other infections or sources, we may get calls for additional susceptibility testing that on its face may not make much sense, but in light of the entirety of the patient's clinical scenario, may be reasonable. And so those are things that we have to look at on a case-by-case basis. Additionally, laboratory workflows may drive some of these differences so that we have plates read on the first and second shift, but if your laboratory is only reading on first shift or has different workflows on first and second or third shift, there may be different statuses that may prompt questions from clinicians that can't be easily addressed via a canned comment because of differences when the specimen hits the laboratory. So how have our calls changed? How did our calls change over the course of the study, and how we've been monitoring this since then? So as I said, calls about mixed cultures did not change. If anything, they've gone up a little bit as there's increasing concerns about resistant organisms or ruling out resistant organisms. And these often require direct review of the plates as well as direct conversations with the attendings or fellows who are covering the patients. We have been getting more requests to rule out organisms, rule out, resistant E. coli, rule out resistant club pneumos and the like. So we actually developed a standardized comment that we call NOMAC for when there's no growth on the McConkey auger. That may be added by the technologist reviewing those plates that says there's no Pseudomonas, Acinetobacter, Stenotrophomonas, or enterogram-negative rods isolated. So this is a standardized comment that's manually added rather than a canned comment being automatically added to cultures. We've noted that the calls that we're receiving for susceptibility testing have shifted so that we're getting more calls for tigecycline, daptomycin, and new beta-lactam lactamase inhibitor combos. And so in order to reduce these calls, we started protocolizing these drugs, automatically setting them up in some cases on resistant organisms or on body sites with specific organisms seen. We do continue to receive calls for potentially inappropriate drugs, such as fosomycin testing on non-E. coli or non-urine specimens. And so we actually have developed a common script for the techs and a common script for the residents to help discourage this. And we've actually seen better uptake and better impact of decreasing calls along those lines. Our next steps are to increase our use of comments detailing the intrinsic resistance of organisms. So not just necessarily not reporting them or not testing them, but explicitly telling providers that the organism may be intrinsically resistant to the to particular drug classes, to try to decrease the calls, but also increase patient care by discouraging the use of those drugs. Additionally, we've started to incorporate comments pertaining to pharmacology into our cultures, so that when we see a yeast growing from the urinary tract, we say echinocandins do not achieve high concentrations in the urine. Alternative therapy should be considered because we were seeing a lot of calls asking for these in the urine. And so by saying this explicitly with the basis for it, we've decreased the calls associated with that. So to summarize and conclude, I think there was great benefit for us for systematically documenting provider interactions with the lab, and it helped identify recurring calls or requests beyond, laboratory anecdata. I think our canned comments effectively conveyed additional information to providers to help relieve the burden of calls to the laboratory so that techs can continue to work their benches and focus on the cultures in front of them rather than be distracted by phone calls. The new availability of drugs, emerging and increasing resistance mechanisms, as well as extremely sick, complex patients, make it very, very unlikely, I'd say impossible, that canned comments can cover all scenarios that we may be asked to address. And I think we were particularly successful and continue to be successful by working very, very closely with our local antimicrobial stewardship team and use institutional guidelines and committees to be a little more proactive or proscriptive in developing our comments to help providers. I'd like to acknowledge Heather Ruff, Hussein Poonawala, and Chris Sebastian, who were fellows and residents respectively, who worked with us on this project. I'd like to thank our antimicrobial stewardship team, as well as the microbiology laboratory staff. I want to thank you for your attention and your time. Hello, my name is David Pieper. I'm an associate professor of laboratory medicine at the Yale School of Medicine and the director of the microbiology laboratory at Yale New Haven Hospital. I'd like to thank the organizers for inviting me to speak today on guiding physicians in the understanding of microbiology results through the use of interpretive
So our
comments.
next speaker is Professor
I have these disclosures,
Hassan,
none of which are relevant to the topics I'll be presenting
name needs
today.
no introduction. She is the pioneer of development of clinical microbiology services at Khan University, and her work has inspired development of many national level policies and guidelines. But here she will be talking about something which is now becoming very close to our hearts. Her title is Clinical Microbiology in an Era of Automation and Near Patient Testing, Indispensable or Obsolete. So let's all welcome Dr. Meena Hassan.
Oh, what have I done? Yes, सिखा दो मुझे, please.
This is not working. I don't know.
Or indeed, as in the lower case, you can take the specimen directly and the machine can identify it and do susceptibility testing. So then what does the microbiologist do? Okay. Okay. Of course, you're all familiar with arrays. Just to discuss the principle of arrays, what happens is you have these platforms or plastic cards on which different nucleic acids are attached, and then they're washed with bacterial or pathogen DNA, RNA, which attaches to the specific nucleotide, and you can sequence it and you can detect it using different detection modalities. And by this, in one card, you can test a whole panel of organisms, and you have these arrays. You have syndromic arrays for gastroenteritis pathogens, you have sepsis arrays, you have respiratory arrays for both bacterial and viral and fungal and anything else. And it can test all these lots of organisms at one go. The other area which may be causing concern is the fact the increasing role of microbiome, and including virome, where it is thought to influence susceptibility to infection, determine the response to therapy, and of course, from transmission from mother to child. So the concern is, where will the clinical microbiologists fit in there? Will there remain a role for them when all this comes into being and all this is implemented? What will the microbiologists do? Do we become redundant? Another thing, of course, there's a lot of talk on personalized medicine, and the prognostic markers and markers to monitor response to therapy. For example, if for the pathogen side, you can do cell-free DNA or cell-free RNA to detect pathogens. You can just take a little blood drop and put it in a machine. It'll tell you कि इसमें पुनः pathogen का DNA है या RNA है. You can look at host cytokines, the patient cytokines, immune markers associated with infection, and see they can not just detect, but you can see the prognostic markers. If the cytokine parameters change as a prognostic marker for response to therapy. So then, and of course, host transcriptomics. What is transcriptomics? Transcriptomics is when the gene is translated into the RNA, and the RNA then becomes protein. So you detect at the level of the RNA to see which gene is being activated at what level. So which gene is responding. For example, in a patient with TB for tuberculosis, they have identified a number of signatures, a number of genes that are activated, and you look at those RNAs and use them as a marker for as prognostic markers and response to therapy. Because now our emphasis is to detect patients early, to tell their prognosis, and to monitor the therapy, particularly for tuberculosis, to monitor therapy to see if you need to change in between, not to wait until the patient shows clinical features of failure. Then that's too late. So the emphasis is to monitor the patient and detect as they go along and start changing therapy accordingly. The other concern, which I don't know if people have, but one possibility that I was thinking would be, because now in the era of increasing antimicrobial resistance, there's a lot of effort in using the host's immune response to control the infection itself. Again, this is from tuberculosis, an area that I'm perhaps more familiar with, and it looks at, for example, in one way you have the pathogen, and what it does is enters the host and prevents the fusion of the phagosome with lysosome. But they are adding new compounds to increase, for example, vitamin D and other compounds to increase the phagolysosome fusion, to kill the bacteria. They may be host cytokines that may be boosted to help kill the bacteria. And then other things like vitamin D, which is being given to help. So then where does antimicrobial susceptibility testing come in? Where is the role of microbiologists in all this? So these activities are used to neutralize the host's activities used to neutralize the pathogens, their virulence factors, boost the host's bactericidal activity, enhanced leukocyte enhancement, so recruitment. So people are wondering, with all this information being thrown at them, of course there are questions arising in people's minds, and they want to know where will our subject be in 5 years' time? Where will we be? What will we do? A very genuine concern. Big data in clinical microbiology. Of course, big data you have heard about everywhere. And now, with increased emphasis on personalized medicine, the antimicrobial susceptibility will be merged with the patient's risk profiles online using electronic medical health records, and to see which drug will be used for which patient, if he has diabetes, if he has hypertension, he has renal failure, which drug is the best match, and that is coming. Analysis of course, protein profiles on Molotov to see what the bugs are and how they will be used for therapy. Variation in antimicrobial system testing, we do it visually at the moment to see in our laboratory how is the system testing changing. But now it will be done through big data, and you have to, and laboratorians, microbiologists will be reviewing this to see how their bugs are changing, what advice will they have to give. And of course, there's improved imaging of next-gen sequencing and data analysis as well. Of course, there are challenges at the moment. Everything becomes with a challenge. I mean, initially when we heard of PCR, we said, oh, kabhi PCR yahan nahi aayega. Now everybody has a PCR. So it doesn't take long for technology to come. It doesn't take long for us to adopt technologies, and technologies become cheaper. Computing power will be required, but we'll get it. We'll have to have microbiologists trained in bioinformatics. So we have to think for that. And you can only prepare people if you know what is coming, you think in advance, and you change your practices and your learning accordingly. So we know that bioinformatics will be required. And you have to have training for that. Artificial intelligence programs will be needed to perform analysis. We talked about artificial intelligence yesterday in monitoring the risks with following global climate change and global warming. So it will also be used for perform analysis of patients and the susceptibility testing, and maybe the genomic analysis from bugs. We will, of course, the challenge will be that microbiological specimens vary, so we will have to adapt with that, particularly in our practices where specimens come from all over the place. So that will have to be considered. Of course, we have to integrate laboratory information system with electronic medical records, and that is an expensive enterprise, but it's something we have to keep in mind to facilitate the data analysis. And we have to have provider buy-in from the ID physicians, from the patients, from the consultants, from the laboratories, from the authorities, from the leadership of the institutions. We'll need this buy-in, but we have to think that is where the field is going and keep this in mind before we before it becomes too late. Of course, the other thing that's causing much concern following COVID in particular was there always, but of course COVID is exacerbated. We knew about for diabetes, we have glucometers and BP instruments and blood oxygen monitoring devices, which before I remember running and doing it arterial blood gas and running with it to the lab in ice. Now you have a little thing, you put it in your finger. And things are going to change. So yes, from benchtop platforms to transportable to portable to handheld to wearable devices. And this will be for infectious diseases also. What will microbiologists do? Are they redundant? They won't be redundant, I promise you. But you have to be prepared for this, okay? And I think this is what the organizers had in mind when they asked me to give this talk. It's obviously causing an anxiety somewhere. And the devices, what are smart, these little portable devices? Well, they are devices that look at different methodology, like microfluidics. Microfluidics is a little chip with the squiggly line. It is a card in which there is sort of these tubes, very fine tubes through which the reagents and the samples will mix, and there is a readout detection monitoring. And you can do, hopefully in the field, through a finger prick, put the finger prick in the machine, it will tell you if you have typhoid or if you have some other infection, hopefully. And we have plastic cards, we have paper assays, similar assays, lateral flow assays like for COVID, for malaria, but we have it for other things also. Small gene expert equivalent. Then we have these plasmonic technologies, which is even smaller, and they use these the interaction between light and rare metals. I don't know the details, I just read about it myself, but basically, based on that, they can have readouts which they detect. And they looked at host markers, antibodies, cells like CD4 cells, mRNA, host mRNA signatures transcriptomic signatures, but also pathogen DNA, RNA markers, circulating microRNA from pathogens, pathogen proteins, antigens. What will the laboratory do when all this is coming? So the questions that my colleagues ask is genuine. The concern is genuine. I'm glad they raised this issue today, where we can prepare for what is coming. And the leadership is there, and they will, I'm sure, also be concerned. But I put this, and this is where the world is going. But where are we? So in Pakistan, I did a Google search, and according to it, we have about 0.63 beds per 1,000 population. That's the figure I got. I don't know if it's true or not, but that's what Google said. So number of beds, according to this, is 132,000 or 133,000. Number of registered doctors is about 245,000. I guess there must be more doctors. This is the registered one. There must be more unregistered doctors. But then I did a poll. I went around asking, how many ID infectious disease microbes do you think there are in the country? And I was told 50, 60, 70. So I was generous. I said maybe between 100 and 250. I don't know. That was I couldn't believe only 60. I didn't believe it. So I said, okay, maybe 100 and 250. This was my estimate. So based on that 250, we have between 0.08 and 0.2 ID micro doctors per 100 population combined, okay? We have 220 million population. So based on that, per 100 persons, per 100 hospital beds, we have between 0.08 and 0.2. In Europe, if I looked, they have ID, infection control, and clinical microbiology together. So they've lumped them, and they've said that in Europe, it is between 1 or less than 1 and 4 in different countries. ID, infection control, and clinical microbiologists per 100 hospital beds, okay? And our data is 0.08 and 0.2 per 100 hospital beds. If my calculation is right, this is what Google. Maybe I'm wrong, but I'm just telling you what I got, okay?
I think, in fact, because I think your beds will be much more, and the number of IDs micro is.
It'll be between 60 and 250. Anyway, so that is what, Then I got this from the Global Burden of Disease. This is from 2019. And the orange is the burden of infectious diseases. Blue is the burden of non-communicable diseases. And green is the burden of injuries. That is how they present. And because it's a burden, disability adjusted life daily burden, so the size of the colors is the burden of that problem. So if you look at our burden, orange predominates. So, or maybe is equal to the blue. So we have a huge burden of infection or communicable diseases, which the West may not. Yet our team to address this is so small. Yes? It is concerning in a population of 220 million. What is it? Then a recent paper. This is published on AMR Day, 21st of November this year, and this data looks at the age standardized mortality rate per 100,000 populations. They took 33 pathogens. They took 11 syndromes and 33 pathogens. So they looked typhoid, they did meningitis, they did sepsis, they did infection. So 11 syndromes. The reference is here. It's just this month's Lancet. And they looked at mortality caused by these pathogens. And unfortunately, and the color, the age-adjusted mortality is here, and the red is between 200 and 394 is the highest mortality rate bracket that they found. Unfortunately, Pakistan, Afghanistan, and Central Western Africa has the highest mortality rate. So we have one of the highest mortality rates due to these organisms globally. And which is actually something to be concerned about, something that we need to think as we move forward in planning our disciplines, in planning our trainings, in readying us to deal with this problem that we have. The bugs the leading bugs that they identified in this table, by the way, was Staph aureus, E. coli, Strep pneumo, Kleb pneumo, and Pseudomonas aeruginosa. But there were other bugs here. And you can look at the paper, just 21st of November, Lancet. It's a very detailed, interesting paper. So this is where we are in Pakistan. If you look at vaccination, vaccination has a role. And this is from the Pakistan Social Living Standard Measurement Survey for 2019-2020, which is the latest that I could find. And for Balochistan, if you look at the red, pink, and brown, that constitute under 50% of non-vaccinated. Sorry, that shows that almost more than 50% are not vaccinated. The red, pink, and the brown areas. So that reflects huge areas of Balochistan that are not vaccinated. But not just Balochistan, the other one, the other graph, the pie chart is from peri-urban Karachi in 2021. And again, more than half of this is for children, by the way, and more than half the children are either only partially vaccinated or not vaccinated. So we lag behind in vaccination also. Although I agree vaccination is not the only infectious disease preventive therapy, but that's the one measure which I used. So we have a way to go. Yet our team is very small and very fragile, and now many of them are questioning, very insecure, and are questioning, do we have a role? Do we go and do histopathology? Or something else? Okay. The other thing is, of course, you must be aware that what these data capture is very small. Bulk of the people living in rural communities are not aware of what diseases they have. They don't have access to health care, including diagnostics. So they don't even come in the picture, in this picture. Okay. Of course, we heard wonderful talks yesterday about climate change and emerging pathogens, and this is from the COP27 conference that took place in Sharm el-Sheikh just last week. And it says the developing countries with widespread poverty, ineffective governments face the gravest threat from climate change, and they're usually poorly prepared to prevent environmental threats. And Dr. Bushra gave an excellent talk on floods and the devastation they cause. And she made a very good point. She said the diseases were there. Floods only exacerbated them. They didn't come because of the flood, they were there. So if we deal with this ground situation, should there be a threat, we'll be better prepared to deal with it. We have to start working now. And these at risk, they have a risk of countries, including Pakistan, which are at risk. And these entities, Dr. Fatma. So these entities are usually poorly prepared to detect emerging pathogens, and they highlight a need for enhancing capacity to detect these pathogens. And hence, I think that is why my colleagues are raising this issue. Okay, so is there demand for microbiology? This was a part of a study we did, and we launched an MOOCs, massive online open course for clinical microbiology. And the study the thing is still going on, but we were monitored only for 1.5 years, from between 2018 and 2020. And we saw there was a huge uptake of these MOOCs. So people were participating and accessing these MOOCs all across the country, from Swat and, yeah, from Swat, KP, all the way down to Sindh. So there is a demand, there is a need, obviously, for microbiology. People feel that they still need it, and they need help in getting there. So, clinical microbiology in Pakistan, indispensable, obsolete, is the question that I was asked to answer. Okay, so when man began transport, he began to walk first. Then he caught an animal and began riding a donkey or a horse or an ostrich or whatever. And then he developed a sailing ship, he developed a steam train, a bicycle, a car that you had to crank to start those cars, and then jet engines, right? What do we do now? Well, no, but we use the car, we also use the motorbike, we also use cycle. And this is from a Western country. This is not a developing country. We still use the bicycle. We still use motorbike. We still walk, very much so. We use this, and this is important in many parts of the world. It is very important. We also use this, right? So we need all. Nothing is, don't feel insecure. Nothing is indispensable. Yes. Okay. So this is microbiology, all right? So we need the microscope, we need serology, we need immunoassays.
For all automatic things to interpret, we need to have like human.
You need humans.
Even for jet and...
Of course, you need a pilot, yes. Yeah. So we need microbiology cultures, we need mass spec like Molotov, and we need molecular, we need all. But everything is required. Now, I was reflecting in the recent past. Dr. Afia gave a talk on NTMs yesterday, non-tuberculous mycobacteria. How were they detected? On gram stain. She said they were a broken, gram-positive broken rod, which she picked up. Naegleria. It was on a wet prep. Those things were moving around on a wet prep. XTR typhi on a simple traditional plate and discs, right? XTR TB on phenotypic sensitive testing. So it is still very important, but you have to be well prepared, you have to be alert and detect anything unusual. You have to be ready to pick up the unusual and question, ask your colleagues, what is this? I haven't seen this. Is this an error or is this real? You have to have your antenna because emerging pathogens don't tell you, okay, hey, we're coming. They're just there. You have to be there to detect them. You have to be aware and alert and pick them up, okay? Yes, molecular tools will be required, but it will probably be fed in from the microscope, I suppose. So we'll need all this, but we have to work together. And like the jet engine, we don't all fly the jet, we all travel in it. So we may not all do molecular, but we can use it, yeah? So you have to have but anyway, this will all be, and we will use all of it, inshallah. So there's growing interest in also another thing that is coming. There's a huge interest in laboratory diagnostic stewardship and its role in test utilization and controlling cost to optimize patient care. We don't need, for example, wound culture and all. We may not need. So look, except the irrelevant from what is actually required. We may not need TB testing and everything, but we have to see if it's genuine, then you do it. So that diagnostic testing, and what tests we don't need, maybe microscopy will do with cultures, or you don't need MALDI or targeted sequencing and everything. So we'll have to guide physicians or people who ask us what is the most cost-effective and practical, quickest test to do. Ordering the right test for the right patient at the right time. Dr. Fareen Ali sitting here works at the NICVD, and first thing she said was when I first got there, she was very desperate to have a good microbiology lab. She couldn't function without a microbiology lab because she needed this kind of input. So we need input from microbiologists. Of course, there's a very close partnership between clinicians and laboratory professionals, as Dr. People's talk prepared. It was an excellent talk to set the stage for this. The close communication, the phone calls that we answer, the guidance, and in our case, they focused on Yale Hospital, but microbiology labs in the nation serve not just hospital patients, but also other patients. We have a huge network of physicians and patients. We have to advise them. Not all of them have access to ID. Microbiologists have to be prepared enough to talk to these patients, or more important, talk to their physicians. Many of them may be GPs sitting in some corner of remote corner who may, and IDs may not have access to an ID physician because they must be in a tertiary care. For them to go to a tertiary care, sit in the doctor's clinic, wait for an appointment, pay the cost, is difficult. So microbiologists have to have this communication with the clinicians and make sure the results are interpreted correctly. Even David People's talk, one of the main things they did was interpret results in a timely manner and a guide for treatment and what is the limitation of your tests and what should they be doing in collaboration with the antibiotic stewardship program as they do in Yale. So the clinical microbiologist, just to investigate, this, by the way, is taken from the Royal College of Physicians, of Pathologists bulletin, where they describe the jobs of micro. The job is to investigate the patient with suspected infection, advise about specimen collection and testing, see patients with complicated infections directly, and advise about antibiotics, and often, if available, in collaboration with the ID physician. If where necessary, where available. If it's something simple, you can do it, but if you complicate, you have to ask an ID physician together with the ID physician, if we're required. Study the microorganisms, test for testing, developing new test methods, advise physicians to correct antimicrobial agents to minimize antimicrobial resistance, of course, part of the stewardship. Be on alert for emerging. As the world gets warmer and warmer, as our infrastructure gets poorer or doesn't improve, we will need this. We have to be alert. Then, as I said, you have to be just aware. You have to be open eyes, open minds to see क्या मुख्तलिफ है, क्यों है मुख्तलिफ. Infection control, which is the forefront of prevention management of healthcare-related infections. Public health role. We have to notify the public health. We have to work with the public health authorities, okay? And of course, we have to contribute to the national vaccination strategies based on what bugs we see. So what do? We have to expand our knowledge base. We have to be always learning. Learn new skills, learn genomics, learn proteomics. Don't be scared. You know, there's this them and us. वो molecular वाले हैं, हम micro वाले हैं. भाई नहीं, भाई सब एक हैं. सब they're all working towards the patient. Why this barrier? Who's created the barrier? It's us that creates barriers. Learn. We have colleagues who've gone and spent years, a year or so, learning this and come back. You have molecular colleagues. Work with them together. Learn this. Learn epidemiology and learn public health policy. Learn data analysis. Learn to handle big data. Learn bioinformatics. What's stopping you? Talk the language of new and emerging technologies. Unless you talk the language, you will still think you're in the 18th century. You have to talk the language. Talk about these DNA and RNA or whatever, and you will feel comfortable with it. Strengthen the clinical base. Many of us, and I'll come to this in a minute, and you need innovation in undergrad, graduates, and project program to ready them for the new world. That is the new world we glimpse now. You have to prepare them for that, and it is our duty, and if we don't, we have failed them. We have to advocate for the critical issues, promoting the growth of microbiology, infectious disease concerns that are in our environment, in our country, in our setting, public health issues, and of course, infection control. Reach out, collaborate, work with others, and never stop learning. What we do is we pass our FCPS, we get a job, and then we say we've arrived. And that's it. But you know, you never arrive. We should always be a constant learner. You have to keep learning. You can only help yourself. Nobody can help you. Don't stop learning. Just keep on. Read papers and learn. The moment you learn, you're dead. You're gone. Sorry, the moment you stop learning, I apologize. Too much enthusiasm. The moment you stop learning, you're dead. Okay, so I just want to share some thoughts which I looked at the US curriculum. And the US has a 5 years college program, 4-year college program, 4-year medical college. Okay, undergrad 4 years, then 4 years medical. So to say they're 8 years when they come for post-graduation. The medical college degree is after 8 years. 4 years college, 4 years medical school. So after 8 years, then they do a 3 to 4 years residency and 1 year micro, 5 years. Or they do 3 years internal medicine, they do their boards. Then they do a fellowship in infectious diseases, 2 to 3 years, and 1 year. So it comes to be a 13-year training program. And Dr. Pieper, if you notice, they had an MD plus a PhD. Many of them also do MD, PhDs, okay? So this is what they do. They also have doctoral scientists who go in, but they go in with a PhD, and they do a fellowship in microbiology with or without MD, and they take an exam. Okay? At each level, there's an exam. The UK UK is 5 years medical school, 2 years foundation course. So they begin at 7 years. Then they do an MRCP, 2 years, that's 9. Then they do combined infectious disease training and do part 1 FCPS on infection after that. 11, and then they do a part 2 microbiology, 13 years, right? You can also have clinical scientists who go in after BSc, but then they have a specialist training, which is a 5-year training, and they have defined jobs that they have to do, okay? What do? We have a 5-year MBBS, 1-year house job, 6 years. Then we are proposing a 2-year general rotation in all chemistry, histopathology, hematology, molecular, okay? So we have 2 years of micro only. We come out as an FCPS with a 2-year micro. No, Moisa will do questions later. So, does that ready them? I mean, look at where the world is going. Look at the onslaught of what we're facing. Do you think this is enough for us? Are we doing our patients, our community, our physicians justice with this? And yesterday, when I first told, so is this sufficient to prepare micro? And I've had this discussion for a long time. And Afia told me many, many years ago, Rumina, koi jo hai aur iske baad koi padhna nahi chahega. They all want to finish and become consultants. And Dr. Faisal Mahmood said the same thing yesterday, koi nahi chahega ye padhna. But look at where the world is going, look at where we are, and look at our burden of infections, look at our infrastructure. What do we need? We need people to detect. We can't. So we have, what are the gaps? We have limited exposures to clinical medicine, which is very important. If you want to work with patients, you have to have stronger clinical medicine. 5-year medical school is not enough, in which you do surgery and obs and gynae and pediatrics and anatomy and physiology. We need to introduce molecular testing. I mean, there's no two ways about it. Genomics and omics. Public health. It's important that we alert our trainees to public health issues. But how will they become good public health physicians if they don't know epidemiology, data handling? So we have to think. I don't have a solution. I was only asked to address this question. Is it time for us to change? And this is a quote which, in fact, Dr. Salman Kirmani reminded me yesterday. It's from Darwin. He says, it is not the strongest of the species that survives, nor the most intelligent. It is the one that is most adaptable to change. Okay? And if we don't do that, we become a fossil. A beautiful flower in an amber, but it's a fossil, okay? We don't want to go there. So thank you very much.
So we can have 5 minutes for questions and answers if anyone has. Dr. Aram, yes.
The comment is that as we have added biotechnology and bioinformatics in the microbiology field, we have increased the play land of the microbiology at a large scale. That is why we are facing problems to complete that. These were two separate fields, and we intermingled them to increase the research level and the other things, and the diagnostic facilities. So that is why microbiologists have to do more things to learn to compete all these new.
Yes.
Yes.
Bioinformatics, molecular are tools. They are tools. They are just like you drive a car, you learn it's a tool. Car is a tool. So you have to learn to drive it. It is not. It's not. You use it in histopathology, hematology. It's a tool. It's a method.
I think I must congratulate the author of this title. This is a very, very important and pertinent burning question. Whosoever has conceived this idea, I must congratulate.
Actually, I wanted to have a debate.
This question is often raised in our setup as well, where I work, in armed forces. And the usual answer that we give to them is that we all fly. We all fly for long hours, and we know that most part of the journey, the jet is on autopilot, but you still have a pilot, you still have a co-pilot, you still have the first officer and all the crew. So you can't ask us, the 300 or 400 people who are traveling, can we rely on an autopilot for all the time? We can't. Number one. Number two, I think this question that was raised, and you have answered it very correctly and very adequately. The point that we discussed over a cup of tea yesterday needs a lot of pondering. Are we prepared to go for the future generations?
Yes.
For just only 1 year or 2 year? Some of my colleagues are sitting who have taken exemption for MPhil. On the basis of MPhil, and they are going for 2 years of FCPS program. I think time has come to revisit this whole curriculum, and in order to safeguard the future of our future generations. Rabia, what do you think?
Moise khade mein, I think.
No, just don't comment. Now you have just become consultant. So what is your thought about this question which has been raised?
Sir, it was so much thought-provoking, so much thought-provoking. Like ma'am said that, Dr. Akia said that, कोई नहीं पता चलेगा. बाकी ये दफा बैठे feeling ये आती है कि शुक्र है आप जान हो. लेकिन ये सुन के इतना कुछ नया पता चला कि इतना लगा कि नहीं, we are so much deficient. There's a lot to do, there's a lot to study. और मतलब सही बात है कि मैम ने जज्बा लगाया है.
I want to answer your question about the flying with a jet. We all, before we could use cycles, now we all drive cars. We learn to drive a car. And if we didn't, we'd still be on a cycle or maybe walking. So at time, yes, not everything, but we have to start, is my argument.
Yes.
Yeah. Thank you so much, Dr. Amina, for highlighting this important issue. Actually, the role of microbiologist जो है ना वो कभी ख़त्म नहीं हो सकता.
अच्छा.
Because I'm telling you, because मुझे ये बताइए कि before that जब हम पहले प्लेट्स के ऊपर और रूटीन के सारे काम कर रहे थे, before that या ब्लड कल्चर की ऑटोमेशन प्रॉपर हर जगह पे अवेलेबल नहीं थी. We don't have answer to the physicians. अगर वो हमसे कुछ पूछते थे तो हम कहते थे ओके वेट करें, हम आपको 2 दिन के बाद बताएंगे. अब ऑटोमेशन का एडवांटेज ये हो गया है, नो वी आर एबल टू इंटरप्रेट, और उनको हम हेल्प कर देते हैं. जो हमने नया कॉन्सेप्ट दिया एंटीबायोटिक स्टूवर्डशिप में, एंटीबायोटिक टाइम आउट, तो हम इमीडिएटली उसको, बिकॉज व्हाट वी हैव टू टेल देम विद इन 72 आवर्स या 42 to 72 आवर्स. सो दिस ऑटोमेशन विल हेल्प बोथ नॉट ओनली क्लिनिशियंस बट ऑल्सो द माइक्रोबायोलॉजिस्ट. सो ये इसके बगैर हो नहीं सकता था. तो ये साथ चीज़ें चलती रहेंगी. वही वाली बात है, पायलट अपना काम करते रहेंगे, मशीनें अपना काम करती रहेंगी, द थिंग्स विल बी गो ऑन.
जी फरीन.
I think I would absolutely second this because, in fact, meaning if automation were to make anyone obsolete, it would probably be clinicians, because with algorithms and with diagnostics, the scary part would be. So you are also insecure. Absolutely. Absolutely. But I think it's sort of the fact that automation, like you're saying, is absolutely going to be a support. It frees you to think outside the box. Mm-hmm. So a part of it takes you away from the mundane, which can be put to automation, and leaves you to look and think outside the box. So I think the human element will never go out.
Yeah.
I think this, not only the automation, the artificial intelligence is also coming there.
Yeah.
In the radiology, in the hematology, yesterday I attended molecular microbiology also session there. The things are now becoming on net. The things are becoming internationally available. So still the scientist need is there. Machine cannot decide. They were afraid that if in the scanning, in the histopathology session, if slide moves from one side 1 millimeter on the left, that turns the malignant into benign and benign into malignant. So all facilities, first, second, the technologies are becoming mixing. ELISA, sometimes microbiology was claiming it's my subject, I have to do ELISA. Later on, the molecular came, then genetics. Now the genetics is now common for histopathology, for hematology, for microbiology, everywhere. So the technologies are, we have to face the technologies and we have to work with them. If we stay, no, it's not for me, then you will remain behind.
Yes.
Yeah. Can I just add? I think a wonderful talk, Dr. Rumina. I thoroughly enjoyed it. It made my Sunday morning worth coming. So I think one of the key things that we miss out is that microbiology in it itself means study of organisms. Organisms are changing, organisms are, evolving, and I don't see any reason where you can say, okay, I've learned enough and now I can go home and I've done with it. It's a subject on its own. We have, to be honest, just discovered a very small component of microbiology in it itself. There's a whole lot of virology. We're just dealing with the bacteriology for most of the time and mycology, but the virology in it itself is a big subject. And I think role of microbiologists, as long as the microorganisms are going to live, the microbiologists are going to live there because they are evolving, and the person who is studying after those are going to, we just need to be cognizant of the fact that we need to change as the organisms are changing because we need to capture them and we need to know them. But one last thing, within the whole list that Dr. Rumina presented where the microbiologists really are needed, one more thing to add is the biosafety and biosecurity.
Yeah.
Even till today, the National Institute of Health in USA, the committee of biosafety committee can only be headed by microbiologists because they have a wider insight into the organism's epidemiology and how it's moving. So it is not going to be obsolete. We really have to keep ourselves think in terms that organisms need to be tackled the way they are changing, so we need to change ourselves as well.
Okay, so let's conclude this question and answer session, and the next talk is from, just wait, it's from Dr. Ella Martin. Ella Martin is the Medical Director of Microbiology in the Department of Pathology and Lab Medicine. She is also an Associate Professor in the Dormant Health, and the title of her talk is implementation of current breakpoints in antimicrobial susceptibility testing.
Hello, I am delighted to talk with you today about implementation of current breakpoints in antimicrobial susceptibility testing. I have no financial conflicts of interest to disclose. And by way of introduction, if I were to self-assess myself on a spectrum of my antimicrobial susceptibility testing, or AST, enthusiasm and expertise, with 0 being someone who's not interested at all, and 10 being someone who is so passionate about AST that they're going to have the letters CLSI for Eva tattooed on their knuckles, I myself would rate a 7.5 because susceptibility testing is something that I really enjoy, but also find very challenging, and that I feel like I'm learning something new every day. I am the medical director of a clinical microbiology laboratory at an academic medical center in New Hampshire, USA, that uses multiple AST platforms and methods. And I'm also a member of the College of American Pathologists Microbiology Committee, as well as the CLSI M52 Second Edition Document Development Committee. The M52 is the document that discusses verification of commercial antimicrobial susceptibility test systems. I am not officially representing either of those groups in this talk today, though. Things I want to cover are first to define susceptibility testing breakpoints and why they're important and why we care about them and why they change. And then I want to quickly highlight the College of American Pathologists' new requirements around breakpoints for laboratories, and then finally talk about how to go about implementing those new requirements. So starting off with breakpoints. If we back up and take a 30,000-foot view of susceptibility testing, right, what we're doing in the laboratory is taking a standardized measurement, in vitro measurement of the activity of an antimicrobial agent against a microorganism. And this is, of course, only one part of successfully treating a patient for an infection, right? We need to think about source control, immune status, treatment compliance, et cetera, et cetera. But for our little part in the lab that we play, I want to highlight how important it is for our work in the laboratory to be as standardized as possible so that we're truly comparing apples to apples and producing reliable, accurate results for our patient-facing providers to act on. So much of susceptibility testing done in laboratories today is predicated on the idea of the minimum inhibitory concentration, asking the question of what is the least concentration of drug that's going to inhibit the growth of a bug. So if we have serial doubling dilutions of an antimicrobial agent in our test tubes and we add a standardized inoculum of our superbug to each of those test tubes, incubate overnight, and then see what is the least concentration of drug that is inhibiting the growth of bug, that is our MIC value. Of course, most microbiology laboratories use automated commercial instruments that are generating either true MIC values or MIC equivalent values. In contrast, some laboratories choose to use disk diffusion testing, right, where a fixed concentration of drug is impregnated into a single filter paper disc, which is applied to a lawn of our test organism, and we're going to incubate overnight and measure the zone diameter, the zone of inhibition, which can be done either in a manual or automated fashion. So regardless of whether we're using an MIC method or a disk diffusion method, right, we're going to take that numeric data that's generated by our test system and we need to render an interpretation, right? We're dividing those data up into categories for each particular drug-bug combination that correlate with the probability of a clinical outcome, right? Are you going to be successful treating a patient with that therapy or not? So our aim is to provide clinically meaningful interpretation of our test data. And except for rare urine-only breakpoints, these are typically based on serum achievable levels of drug. Breakpoints are developed using three big buckets of data. The first being for any particular drug-bug combination to look at the MIC distributions of many isolates, right? Looking at what are the MIC values associated with those isolates that are wild type versus the MIC values associated with those strains that have known mechanisms of resistance. And so yeah, what's the dividing line between wild type versus resistant? And then also pharmacokinetic and pharmacodynamic data is taken into account. And then lastly, the most difficult data to come by are clinical outcomes data. Documenting patient failure on therapy when infected with a bug that had a given MIC. Breakpoints are developed by standards development organizations. So within the United States, we have the Clinical and Laboratory Standards Institute, or CLSI, as well as the U.S. Food and Drug Administration, or the U.S. FDA, and specifically within the FDA, the body that is the SDO is the Center for Drug Evaluation and Research. And then in Europe, another global major standards development organization is EUCAST, the European Committee on Antimicrobial Susceptibility Testing. Historically, these SDOs were not completely harmonized in terms of all breakpoints for all bug-drug combinations, but there has been an effort to harmonize as much as possible going forward so that everybody across the globe can be using the same breakpoints eventually, we hope. In the United States, we have a particular regulatory environment that seems to have created challenges within laboratories for staying up to date with susceptibility breakpoints when they change. So there's a problem that is most acute in the US with laboratories not being up to date, but I think internationally as well, awareness about this issue is really important. So we've talked about how both CLSI and FDA are standards development organizations, right? CLSI sets breakpoints. FDA can choose to either adopt CLSI breakpoints or can set their own. Interestingly, when we look at the commercial susceptibility testing device manufacturers, they need to obtain clearance from the FDA to market their device, to market their test system. And when they submit their data to the FDA to get clearance for their product, they must apply the breakpoints that are current at that time, the FDA breakpoints that are current at that time. At the time of submission, and they are under no regulatory obligation to go back and update breakpoints should CLSI or even FDA then change those breakpoints down the road. The manufacturer can continue to market devices that apply obsolete breakpoints. Of course, and it would take quite a lot of resources and a large expense for a device manufacturer to resubmit to the FDA to obtain clearance for different breakpoints on an already approved device. Although there is some work around changing that regulatory pathway to make it easier for device manufacturers. Then, of course, we have our clinical laboratories who want to do the best for patient care that they possibly can. Clinical laboratories often look to CLSI to see what is the best thing they should be doing for patient care. However, historically have often, I think, relied on their device manufacturers to stay up to date with CLSI. However, as we just talked about, that has not actually historically been the case. So why do we care whether or not we're applying up-to-date breakpoints versus obsolete breakpoints? Well, several studies have shown findings similar to this one cited from 2009, that using effective antimicrobial agents saved lives. So this particular study looked at the odds ratio of survival for culture-proven sepsis in those treated with either appropriate versus inappropriate antimicrobials. And this study defined appropriate as an antibiotic that had in vitro activity initiated within 6 hours of the onset of septic shock. And I like this because they look at multiple different organism groups of both bacteria as well as yeast, and found that, you know, an improved odds ratio of survival, this light gray, when a patient was given appropriate antibiotic therapy versus inappropriate. Breakpoints can change or be updated for a variety of different reasons. Sometimes there's emergence of new resistance mechanisms that weren't known about or didn't exist when an initial breakpoint was set. Sometimes new PK/PD data comes to light. Sometimes there are changes in antimicrobial dosing that become common among practitioners and need to be incorporated into breakpoints. Sometimes clinical failures are documented within the susceptible range, and then that susceptible range needs to be changed. Sometimes breakpoints get changed just so that the SDOs can harmonize with each other. Sometimes a drug sponsor will request revision or reanalysis of a breakpoint. And then finally, sometimes a new agent within an antimicrobial class will come to market, and that will prompt review of others in that class that have not had their breakpoints reviewed in a while. So if we take the Enterobacterales breakpoints, it's a great example of just how many breakpoints have changed, really starting in 2010. And so for many of our really major drugs here, so some of these initial breakpoints had been set pre-1987, and then, since 2010, have quite a few have changed. A comprehensive list can be found in the CLSI M100 document. And if we drill down onto one example, looking at just meropenem versus the Enterobacterales, that breakpoint was initially set back in 1998 by CLSI. And that was 3 years before the first KPC carbapenemase was described in 2001. Once carbapenemases came onto the scene, and we started, getting the spread around, we started getting more data. In the early 2000s, it was found that about 12% of KPC producing E. coli and Klebsiella pneumoniae would test susceptible using those initially set breakpoints. And around that time, PK/PD data also were considered. Whoops. And these new data led to CLSI lowering the carbapenem breakpoints in 2010. Notably, it took 2 years before the FDA decided to recognize and adopt those same CLSI breakpoints. So in that 2-year span, a manufacturer wouldn't have been able to get clearance to apply new breakpoints on their devices until the FDA actually had recognized those breakpoints. Once FDA adopted lower carbapenem breakpoints, there was still a concerning delay before clinical laboratories started to really widely adopt lowered meropenem breakpoints and the other carbapenems as well. So here is a listing of the actual old and current breakpoints. So for meropenem, pre-2010, an MIC of less than or equal to 4 would have been interpreted as susceptible, but today an MIC of less than or equal to 1 is needed to be considered susceptible. If we think about what that would mean for a given patient, if we have a 65-year-old woman with sepsis who presents to hospital A, which is still applying obsolete breakpoints, and in her blood culture, we isolate an E. coli, and that E. coli has a meropenem MIC of 2, a laboratory using obsolete breakpoints will interpret that as susceptible, leading the patient-facing providers potentially to treat with meropenem. Let's say she goes to hospital B instead, and that hospital is applying current breakpoints. That same E. coli isolate with an MIC of 2 would be interpreted as resistant with up-to-date breakpoints. And that would prompt our patient-facing providers to look for alternate therapies and enhance her chance of successful treatment. It's also interesting to think about how important it is from an infection prevention standpoint to apply up-to-date breakpoints. This is an interesting couple of modeling studies looking at how implementing up-to-date breakpoints can help avert carriage or colonization of carbapenem-resistant organisms. So starting out, this group found that 8% of their KPC carbapenemase producing isolates would test susceptible to ERDA, IMI, and Miro using obsolete breakpoints. However, were they to use up-to-date breakpoints for doing rectal swab surveillance, looking for carbapenem-resistant organism carriage, that would then lead to contact precautions for patients and hopefully stem the tide of transmission. This study found that using up-to-date breakpoints would avert transmission of thousands of cases of carbapenem-resistant organisms between patients in both acute care hospitals and even more so in nursing homes. So many laboratories, unfortunately, still use obsolete breakpoints. In 2019, some members of the College of American Pathologists sent a survey out as part of the CAP bacteriology proficiency testing survey that gets sent out to laboratories that subscribe. And we queried labs on what breakpoints they were using for select bug-drug combinations where we knew that the FDA and the CLSI agreed on what the breakpoints were. There were no discrepancies between the SDOs. And we received almost 1,500 responses, the vast majority of which were from US laboratories, but also 232 international laboratories responded. And so listed here on this slide are a few different bug-drug combinations and the percentage of US labs that reported using obsolete breakpoints. And we can see that for those breakpoints that changed in 2010, such as ceftazidime, ceftriaxone, and meropenem, around 40% of labs were still using obsolete breakpoints in 2019. And for organism bug drug combinations whose breakpoints had changed more recently, like the fluoroquinolones in 2019, 70% of laboratories continued to use obsolete breakpoints. And interestingly, if we looked at the responses from international laboratories, they were much less likely to use obsolete breakpoints. So for these same bug drug combinations listed on this slide, international laboratories reported only 18 to 44%, depending on the bug drug combo, were using obsolete breakpoints. We additionally asked labs to provide some feedback as to why they continued to use obsolete breakpoints. And the themes that we heard were confusion over whose responsibility it was to update, right? Laboratories thought that manufacturers, their commercial systems were going to automatically stay up to date with those breakpoints, which was not true. And most concerningly, 50% of laboratories using obsolete breakpoints had no plans to update those breakpoints in the near future. So this led to the CAP micro committee to come up with some new requirements around breakpoints. So on this committee, there were numerous discussions about the data generated from that survey that I just referenced. And we deliberated long and hard over whether it made sense to try to nudge laboratories towards more timely adoption of up-to-date breakpoints with a checklist requirement, acknowledging that this would require a lot of work from laboratories as well as from the commercial susceptibility test manufacturers. But ultimately, the patient safety concerns that were inherent with prolonging use of obsolete breakpoints really won out in this deliberation. So first off, the checklist item MIC 11380 is now revised, which basically says that you need to know which breakpoints are currently being applied in your laboratory across all test systems, and know, where is that breakpoint being applied? Is it being applied at the level of the instrument? Is it in your laboratory information system? Is it in your electronic medical record? Where is the breakpoint applied? And then you need to review them annually to make sure that you are thinking about potentially incorporating any changes for different bug drug combinations that get published. And then, even more importantly, is to update any obsolete breakpoints by January 1st, 2024. And so at a minimum, you need to be up to date with FDA breakpoints within 3 years of the date of official publication by the FDA. Because FDA tends to be the standards development organization that lags behind the others a little bit. But you can follow CLSI, you can follow FDA, you can follow UCAST. But at a minimum, you need to be, you can no longer use breakpoints that everybody considers obsolete. So lastly, and very importantly, how do we go about implementing the new CAP requirements? So the first step is to assess what breakpoints are in use. And to do that, you need, if you have an automated commercial system, your commercial manufacturer can help with that. If you're using manual methods like disk diffusion or e-tests, then you're going to need to query the rules that are probably in your lab information system or your electronic medical record, which will require some IT staff assistance, most likely. So my experience, when our manufacturer gave us a printout with a list of various bug drug combinations. This printout was 42 pages long, and we needed to manually transcribe those into an Excel spreadsheet. Unfortunately, the PDF, it wasn't one of those where you could really convert it easily to an Excel document. And then for our gradient diffusion and disk diffusion testing, we had to query our lab information system, and similarly do a manual transcription into a master Excel document so that we had all breakpoints applied in one location. And so this is what part of our spreadsheet looked like, where we listed antimicrobial agent, organism group, test system, and what were the breakpoints being applied. And then lastly, over on the right, what was the location of the breakpoint being applied? Was it in the LIS? Or in the at the instrument, or in the electronic health record. So I will not lie that this is a tedious and painful process, but so important. It creates a reference document that can be used going forward. And I think every lab will be surprised. We'll find some things that they didn't know were out of date. My lab certainly did. And it seems like manufacturers really are still figuring out how to best support users. The next step is to compare your current breakpoints in use with what are current breakpoint standards. So you can either go to FDA, M100, or UCAST. All of these breakpoints are available free online. And you then document, does the breakpoint being applied in your lab match the M100 as of the review date? Does it match the FDA breakpoints as of the review date? I don't have UCAST on my spreadsheet, but that would be totally an acceptable thing to include. When were the breakpoints implemented in the lab, and when was the date of lab review? And then what are your action, potential comments or action plan? And so this spreadsheet is available as a free download on the CLSI website. And here is a high-level view of the beginning of my document. My lab actually uses 2 different commercial manufacturers for automated susceptibility testing, plus some e-tests, plus some distribution. So our document is quite long, but this is a snapshot. And we highlighted in yellow those breakpoints that we found were obsolete or not up to date with at least with CLSI. And then next step is to plan and prioritize your updates. So for automated systems and with panels, think about how many bug-drug combos within a given panel are currently using obsolete breakpoints. And then on that panel, do the dilutions present go low enough to potentially validate sort of off-label breakpoint use? If you need certain background about specific bug-drug combination breakpoint changes, there's a nice publication by Romney Humphreys in the Journal of Clinical Microbiology. There are also CLSI rationale documents that really detail why certain bug-drug combination breakpoints have changed over time. So those are really helpful to just get a better understanding of why things have changed. And then you want to engage with your infectious disease and or antimicrobial stewardship stakeholders and prioritize which breakpoints you want to change and how you're going to go about doing it. So there's a variety of ways one can navigate the presence of applying obsolete breakpoints. You can either verify a brand new panel that applies updated breakpoints. Maybe the manufacturer has come out with a newer version of a panel that does apply current breakpoints. Or you may be able to keep your current panels and validate off-label breakpoints on those current panels, provided the dilutions go low enough. You could alternatively choose to suppress the result of that particular bug-drug combination from reporting. Or you could choose to verify an alternate method for that particular bug-drug combination. Or you could choose to send testing out to a reference laboratory. Many different ways to navigate this. And then, you may end up performing a validation and or a verification, either validation of an off-label breakpoint or verification of a brand new panel. So the scope of that evaluation within the laboratory is, of course, at the medical director's discretion, and as well as the number of isolates you choose to test. If you're doing a verification of something that is FDA cleared and you're using it exactly as the manufacturer intended, right, then you don't need to use quite as many isolates as you would if you are doing a validation of an off-label use. Ideally, you want to choose isolates that span all interpretive categories, and you also want to try to include some contemporaneous patient isolates whenever possible. Of course, fewer isolates, like I said, are needed for FDA-cleared applications and more for off-label. There are many resources available to help guide this process and help people learn about it. So the M52 document has a new edition in progress, but the first edition is also quite a great resource. Back in 2013, Clinical Microbiology newsletter, there was a great practical guide to susceptibility test verification that's quite helpful. And there's also some resources specifically around implementing those lower carbapenem breakpoints. So in summary, using current breakpoints is really important to patient care, to public health, and to antimicrobial stewardship. And there are new breakpoint requirements for those laboratories that are CAP accredited. And they may seem overwhelming at first, but if you break it down into pieces, then hopefully it will not be as onerous as we may anticipate. We want to assess our breakpoints in use, compare them to current breakpoints, strategize and prioritize regarding updating any obsolete breakpoints in use, and then perform any necessary verifications and validations. So I leave you hopefully with some new knowledge around this topic, and also the awareness that there are many resources and tools available to help you along the way. Thank you very much for this opportunity, and enjoy the rest of your conference. Hello, I am delighted to talk with you today.
Before the tea break. And this talk is also going to be very interesting, and because this will talk about a day in the life of a clinical microbiologist. And we will, what Dr. Zishan, who is an assistant professor at Khan University, will be delivering his talk. And what he will be doing, he will be linking the tasks of the microbiologist with the current literature which is available. So over to you, Zishan.
Thank you, Dr. Kausar, for introduction. So, okay. So हम लोग सारे माइक्रोबायोलॉजिस्ट यहाँ बैठे हुए हैं. डॉक्टर मीना ने एक आखिरी स्लाइड जो रॉयल कॉलेज की दिखाई थी, जिसमें बताया था कि हमारे रोल्स, डिफरेंट रोल्स हैं हमारे, जो हम लैब में आते हैं. एंड व्हेन वी कम टू आवर लैब डेली, सो हमारे बहुत सारे चैलेंजेस होते हैं जो हम डेली फेस कर रहे होते हैं. एंड we try to solve these issues with literature support. So this is like, it's my experience for a day. So everyone has different experiences, so I share my one-day experience here. So we have different roles, like we have different challenges, like if we have clinical cases, we have administrative challenges, we have different teaching sessions on which we have different challenges, and we expedite two different solutions. So it was the Monday morning day. I was traveling to hospital after my vacation, with nostalgia of my holidays. Suddenly, I receive a call, and this call is from my first-year resident. And the case was, she said that, sir, I want to report 2 results of phlegm-area meningitis encephalitis panel. But she was concerned that the CSF-DR finding was not correlating with the result. So I asked for the history and DR findings. And the first case was of HIV patient, young patient. He presented with altered mental status with diffuse leptomeningeal enhancement. DR finding was suggestive that low glucose, high protein with predominant lymphocytic count. India Inc. was negative. Physician asked for the biofile, and it turns out to be negative. My resident was very intelligent. She did a cryptococcal antigen assay, and it turns out to be positive. Now she is confused now. Kya kare ab iske liye? Second case, again, a 38-year-old female who presented with short history of back pain, left eye blurring vision, right hand difficulty, and talking difficulty also. Nothing was significant. No MRI was significant. CSF finding was not significant, but fortunately or unfortunately, her human herpes virus 6 comes out to be positive. So again, I pull out my mobile, and during my travel, I started literature search. So usually we consider that PCR are more sensitive and in compared to the serological test or the other Gram-Stain finding. So this is the biofile panel, which has the cryptococcal availability. But for the cryptococcal antigen, like we have limitations. Like it comes positive after several weeks of treatment also. So I evaluated, I pull out the literature, and I found a very important, a very relevant article in which they have evaluated in 2 tertiary care units. They have evaluated the 1,300 frozen CSF samples of HIV patient. All these patients have a positive culture and antigen test. So if we see the result of this study, And we compare the CSF culture result with the ME panel, which was sensitive, 96.4% sensitive. But we compare the cryptococcal antigen CSF with ME panel, it was 83.8% sensitive. And in the same literature, I saw that the low CSF titer, there was the panel was negative as well as the culture was also negative. When the titer was high, it's like 2560, the panel was also positive. So it depends upon the titer of the cryptococcal antigen present in the CSF. So for that, in this case, we reported negative, and we highlighted the case to the physician that the antigen was positive, and we asked for the culture, and told our technologists that inoculate more volume, so can we get a quick yield for the cryptococcus. For the other case, I found another important literature in which they have evaluated a brief report. They have evaluated the human herpes virus positivity, the clinical significance. So in this literature, I found that the PCR positivity alone does not necessarily imply causality, because the viral nucleic acid could be positive in a different state of disease, like latency, latency, viral replication, and chromosomal integration. And it's very rare to have positive in other than the hematopoietic stem cell transplant. So in this study, they retrospectively evaluated 15 positive HHV6 cases, and the medical record was extensively evaluated by the group of people. And out of 15, they found only one likely case that could be significant with the HHV6 positive. And that patient has a hematopoietic stem cell transplant 3 weeks before. He has a limbic enhancement in MRI, and he improved after antiviral therapy. So what we conclude in this is that when we interpret positive HHV6, we should consider the immune status of the patient. That should, like a hematopoietic stem cell transplant within 2 or 6 weeks. We should consider the clinical presentation and MRI findings also. And if viral load in CSF or plasma is available, we should also consider this. If it has a higher viral load, there's a higher chance of positivity and clinical significance. So this was my big start of my day. 8:30 when I reached, everybody knows that we have a morning meeting at 8:30. So my ICU resident presented a case of a 65-year-old male ICU, admitted in ICU with diabetes and necrotizing fasciitis. This patient has surgical debridement, sepsis. He was probably in sepsis, and blood culture, which was sent day before yesterday, it came out positive at midnight, like at 1 a.m. So we do not have sensitivity at that time, but it was gram-negative. On the gram stain, we set all the plate, suspected enterobacteriaceae, and patient was at that time on piperacillin tazobactam. So we have no option. So according to CLSI, we have to check the growth after 18 to 24 hours. So we cannot wait in this situation for the patient with sepsis. So what we did, we advised to broaden the spectrum of antibiotics, and we plan to check the susceptibility from the growth of just like 6 to 8 hours. जो भी growth आई उससे check तो करें sensitivity हमारी क्या आ रही है. And for that, I pull out a literature to support this work. They call it early disc diffusion, and they check this susceptibility of different clinical isolates, which include gram-negative and gram-positive. So initially, they did assessment of 21 clinical isolates. And after that, they validate their results by doing the testing on 100 clinical isolate. What they did, they checked growth sensitivity on 6-hour growth, 10-hour growth, and 24-hour growth, and they compare the result of this. Everything was done according to CLSI recommendations, so I will not go into detail. So they compare first the 6-hour with 24 hours, 21 isolates, and for 10 hours also. And they found a very good agreement of all these results, very good agreement between 86% to 100% for 6 hours, and similar result with after 10 hours of growth. So they further consolidate their findings by optimizing with 100 clinical samples. By the way, they did with the triplicate. All these did in the triplicate, and the result was also very significantly. They have a good agreement on 6-hour growth with the 24-hour growth. So what they conclude is that EDD provides a mean of improving the turnaround time for distribution, especially those labs which have we do not have a we do not have a VITEC or any other MIC system. So they can do on the distribution methods, number one, and they further say that anyone who want to incorporate this in the lab, they should do a very good extensive evaluation before incorporating the workflow. So this was our morning meeting case, and then we started our daily reporting. 9:30, it was urine culture. I was on the urine culture bench, and I found first case of Klebsiella, which was like this. So I have nothing to report, multi-drug resistant, colistin was intermediate. I was thinking, I was scratching my head, what to do now? So I asked my senior technologist, so we have a consignment of ceftazidime avibactam, so we received disk for that. No, we will receive very soon, as usual. And then we have to do validation study and so on. But good thing what she did, she take a printout of a recent article, and I will share that article. So, but we have to do it very quickly because our pharmacy formulary has this very soon. We will receive this drug very soon. So we have to do this validation study very quickly. So, the in and outs of susceptibility testing for new beta-lactam, beta-lactamase inhibitor, especially for gram-negative, in this article. So they have discussed ceftazidime, avibactam, meropenem, revobactam, and imipenem, relibactam. So all these drugs are very good, effective against different resistance mechanism like ESBL, except Ambler class B carbapenemase, NDM. So all these are very good, effective against different mechanism of resistance. But so we have ceftazidime avibactam in our formulary. So I further do literature search, and I saw that the breakpoint was for enterobacterials and pseudomonas were available in both Celiac and UCAS for MIC and disc diffusion. But unfortunately, it was not available for Acinetobacter and other gram-negatives for ceftazidime avibactam. So I started to think, अब क्या करें अगर ये resistant आ जाता है, ये Acinetobacter आता है तो क्या करेंगे इस तरह की situation में किस तरह हम आगे बढ़ेंगे? So testing system जो थे apart from disc diffusion and gradient, other that VITEC, Microscan, Phoenix have all this ceftazidime avibactam available in this system also. So the challenges which we could encounter, जो मैंने anticipate किए, like request अगर कोई कर देता है for Acinetobacter bomni complex, what should we do? और हमें क्या करना पड़ेगा उसके लिए जब इसके breakpoint भी available नहीं है? So probably we have to be preemptive and perform some in-house evaluation, or probably if we have any facility, we have to send it to reference laboratory, or we started to do MICs and started to add some comments in it. अदर प्रॉब्लम जो हो सकती थी वो थे कि वो डिस्क जोन साइजेस जो कि बहुत बॉर्डर लाइन थे, जैसे फॉर इकोलाई जिसके 20 पे सेंसिटिव था एंड इट्स लाइक 21 बहुत नियर आ रहा है, तो we should do some MIC method for confirm this or send to a reference laboratory, similar with the pseudomonas. So we have to make some plan for this new unexpected findings. For Morganella species, we do not have to report and do not have to test. So these are the problems we should anticipate. And so another important finding which I found in the literature is that ceftazidime have resistant also, like different resistant mechanisms have been identified in literature. But important thing is that the method that detect the resistance, like commercial method, has limitation. It's not available anywhere. Broad microdilution has its complex and needs expertise. Disc diffusion do not have a good agreement with BMD. E-test takes 16 to 18 hours. So there's another, I found a literature of RISA's ceftazidime avibactam NP test, which is reliable according to literature, and takes 4 to 5 hours. So I pull out the literature of this also, and I see that this finding recently published. They have tested the non-duplicate enterobacterials of 178 and checked the result with BMD and different other methods. And you can see that they have a very good agreement with the broad microdilution against E. coli, Klebsiella pneumoniae for this NP test. So another role that we have encountered, like I was standing near a telephone, so my friend pulmonologist, pediatric pulmonologist, he called. He said, like, प्लीज़ चेक स्प्यूटम कल्चर फॉर माई पेशेंट हु सिस्टिक फाइब्रोसिस, 8 साल का है, दो दिन पहले इसने स्पेसिमेन जमा कराया है, क्लिनिक में आया है, मुझे बहुत सिक लग रहा है, वांट टू स्टार्ट एंटी सूडोमोनास, प्रीवियस कल्चर में कई दफ़ा सूडोमोनास आ चुका है रिचिनोजा. So I was on my bench, so मैंने कहा हम देखते हैं प्लेट्स देखते हैं क्या है, तो there was no growth after 48 hours. And he was stuck कि क्या करें, is culture 100% reliable in cystic fibrosis? I have no answer at that time, honestly. So I think we should, we decided that we should continue the antibiotics and keep a close follow-up, and we will discuss further on the lunch. So while going to lunch, I pull out again some literature for this, and I found a very interesting literature. They have correlate the findings of a culture with the quantitative PCR. So in cystic fibrosis, we all know that the microbiological surveillance is very important. And there's a question mark that microbiological culture really diagnose accurately, although we consider it as a gold standard. So in this study, they compare the culture with targeted quantitative PCR, especially against the aeruginosa and Pseudomonas aeruginosa and Staph aureus. And they collect prospectively, they collect the respiratory specimen of 20 pediatric and 40 patient total for 3 years. And they consider free from chronic Pseudomonas infection if there's no culture positive in last 1 year. So इसको अगर हम देखें गौर से तो ऊपर वाला जो है Pseudomonas aeruginosa है, नीचे वाला Staph aureus है. This is the culture, this bar, orange bar is culture, and this is the quantitative PCR findings. And this is for Staph aureus similarly. 50 जो mark हो रहा है ये chronicity के लिए कर रहा है, classify chronicity के लिए. So if you see that the culture, one specimen culture was positive for Pseudomonas in 12 patients out of these samples in 3 years, and for Staph aureus in 29. And when they did the quantitative PCR, it was all positive for 40 patients. And therefore, the classification of the chronicity is also changed. Initially, it was only 1% they have labeled as chronic infection, but after PCR, it's changed to 28 and 34% simultaneously. So we discussed this with my colleagues, and we plan to incorporate quantitative PCR or introduce quantitative PCR. So in the same business meeting, which I have with my manager, I come across another important problems which usually we face, that we do not have blood culture bottles. और अभी हमारे पास स्टॉक जो है सिर्फ 1-1.5 महीने का रह गया है. सप्लायर कह रहा है कि सिर्फ Arabic bottles हैं, if we can use only Arabic bottles, consignment हमारा देर से आएगा. I thought it's not a good idea, that we will miss probably organism. But she was insisting कि anaerobic में तो क्या आता है, ज़्यादा anaerobic नहीं grow करते, हम कर लेते हैं कुछ. So I thought no, we should expedite with the supplier, and we should stick with our plan कि हमें दोनों bottles देनी है, एक bottle नहीं देनी है. And for that, I pull out again a literature, that routine use of antimicrobial anaerobic blood culture bottle for specimen collection for adult and pediatrics. So this study was conducted in a big tertiary care unit, and they used the vector alert virtue blood culture system during 1 year, and this number of bottles they have received. And what they found is that they found a significant aerobic positivity rate, 5.8%, with 403 obligate anaerobes. For a pediatric, for adult, and for pediatrics also they have a good similar finding. Important thing is that, which is statistically similar, is that Staph aureus. The recovery of the Staph aureus was better in anaerobic bottles with a good turnaround time in anaerobic bottles. And if they do not use these bottles, like if they use only anaerobic bottle, they probably miss this number of cultures and this number of pathogens. So probably they will miss this number of organs. So I thought we made the right decision कि हमें उसको एक single bottle नहीं देनी चाहिए. ओके, सो ये एक हमारा था कि प्लान हमने कहा इसको ऐसे नहीं करना चाहिए. सो वो जो डॉक्टर मीना कहा था हमारे रोल चेंज हो रहे हैं डेली, तो वो हमारे रोल डेली एक दिन के हिसाब से चेंज हो रहे थे, डिफरेंट चैलेंजेस. सो हम सपोर्ट करते जा रहे थे अपने हर चैलेंज को विद द लिटरेचर सपोर्ट, एंड यही हमारा रोल होता है डे टू डे चैलेंजेस में माइक्रोबायोलॉजी का. तो हम एविडेंस बेस्ड प्रैक्टिस कर रहे हैं ताकि हम किसी चीज़ में कोई चीज़ हम मिस ना कर रहे हो ना. एक लास्ट ही जो हम सबका एक रोल होता है माइक्रोबायोलॉजी में कि रोटेटिंग रेजिडेंट या रेजिडेंट की टीचिंग एंड ट्रेनिंग, जो कि हम सब कहीं ना कहीं किसी लेवल पे इन्वॉल्व होते हैं. एंड विद द सर्विस आई नो कि हमारी हर वक्त ना एक होती है कि सर्विस काम हो जाए, टीचिंग थोड़ा सा हो जाए, ये एक हमेशा जंग रहती है ना. सो एक कन्वेंशनल मेथड्स होते हैं, लेक्चर हो गया, इस तरह की चीज़ें हो गई, ट्यूटोरियल्स हो गए, बट आई थॉट रोटेटिंग रेजिडेंट था. आई आस्क्ड के हाउ इज रोटेशन गोइंग. सो he was quite satisfied and with the rotation, and so I thought I asked, do you feel any room for improvement? So he told me that I think there should be more interactive sessions, and I thought, how can we make more interactive session? हम सब busy हैं, कुछ ना कुछ किस तरह करेंगे. So Dr. Kausar ने थोड़ा सा उसमें गाइड किया as usual. हमारे पास टाइम है, एक वीडियो अगर चला दें थोड़ी सी, इसको वीडियो प्लीज चला देंगे. मैं यहाँ से शायद नहीं चला पाऊंगा. सो ये escape room एक नई हमने देखा कि escape room है, कि escape room किस तरह यूज हो रहा है.
Hi, my name is Janine Valco, and I'm a simulation education manager for Allegheny Health Network. Escape rooms offer a wonderful environment to help build problem-solving skills, clinical skills, communication skills, and leadership skills. The simulation escape room is a gamification modality. Participants come into the room, the door locks behind them, and the participants are given the challenge to solve puzzles and complete tasks. What inspired me to start using simulation escape rooms was first that the foundation in the simulation center is the perfect setting. Everything is there. The nuts and bolts are there for you to go ahead and build. But not only that, some of the education that we offer, it seems to get stale, so we wanted to provide a gamification concept in learning. Learners actually love the escape room modality. Initially, they're a little bit apprehensive, but after they go through it, they have so much fun and they're so engaged while they're opening the puzzles and completing the tasks. Tips for creating a simulation escape room would really be to sit down and go through exactly what learning objectives you'd like to complete and accomplish. One other thing that I would certainly recommend is that if you have the opportunity to go visit an escape room, a public escape room, you would get great ideas to help develop your own escape room. What I would offer to folks that are kind of concerned about beginning an escape room is to try to keep it small, to build a script to start with, and then a puzzle that would attach to each step of the script. Simulation escape rooms positively influence learning outcomes because it's a gamification in learning, and we've learned that game-based learning creates fun in learning and it makes learning stick.
So escape room basically कमरे में बंद कर दिया, different objectives थे, उसको उन्होंने fulfill करना था. So it has been used in different, so it's a game-based learning, and it has been used in different purposes like recruitment, especially in nursing, promoting active learning, and these are different purposes to develop escape room. So we have virtual escape room. So इसके लिए भी हमने literature देखा, तो उसमें इन्होंने क्या किया कि दो big teaching hospital थे US में, उनके ER के जो emergency room के जो resident थे, उसको उन्होंने evaluate किया for infectious disease content, and what they found that there are different postgraduate years for year 1 to year 3, and they have different objective of like different infectious diseases. They put it in one objective, 1 to 3 objective, and objective 4 to 6 are different infectious diseases. And they did the pre-test and post-test for that, and they switched the like two hospitals. They give the different options. They did the lectures, and they did the escape room also. And after that, they evaluated the results. So if you see that the escape room result was for this is like a pre-quiz. In post-quiz, this has improved also. And similarly for the lecture, it was not improved significantly. There was no significant difference, but number has improved in this escape room in both hospitals, this hospital and this hospital. So I thought this is a good idea to incorporate this also. So while going back home, I thought what I have done today. So I play different, I come across different challenges, and I found that with emerging infectious disease and complex clinical cases, the role and responsibility of consultant microbiology has also become dynamics. So we have to be more dynamics in our approach and simultaneously incorporate all these things in our teaching and daily routines. So that's it. That's it from my side.
So I think Dr. Dishan did an excellent job in delivering what I had envisioned for this presentation. So now we can break for tea and come back again at 11:30. Okay, so we have some presentations and some quizzes for the last part of the meeting, and we have to end this session by 1 p.m. So this is the deadline that we need to. मनीबा तुमने वो सेटअप कर दी है माइक्रो बूस्टर्स वाली? So welcome back again. बिल्कुल बुलाएं. We are very like have to be on time. अभी बहुत चीजें हैं. पहले तो माइक्रो बूस्टर्स का मनीबा सेटअप करा लें. सेट हो गया है. तुम वो हो बेटा अस्का है ना? हाँ मैं ठीक करना शुरू. हाँ रख दो भाई, बिल्कुल टाइम पे होना है, लंबा नहीं जाना है. So the next activity is micro boosters. So these are the short videos which have been developed by our clinical microbiology trainees from different centers, and where they will be giving tips on different small activities. So let's play it.
Bismillahirrahmanirrahim. Assalamu alaikum everyone. My name is Dr. Fareen Sheikh, third year resident microbiology at Ziauddin University Hospital. It is an honor and privilege for me to present my topic in front of all respectable teachers, seniors and colleagues. Thank you so much for giving me this opportunity. Today the topic of my presentation is antibiotic QC, why are my zones small? Specific learning objectives are able to understand briefly about an antibiotic risk and zone of inhibition, probable causes and suggested actions. Antibiotic disc. An antibiotic disc is a small circular piece of filter paper which has been impregnated with an antibiotic solution and allowed to dry. The discs are used to find out which antibiotics an affected organism is sensitive to so that doctors know what drug to prescribe. Zone of inhibition. Zone of inhibition caused by the antibiotic is measured, giving an idea of how effective the antibiotic is against a particular bacterium. The size of the zone of inhibition in a disc diffusion test depends both on how effective the antibiotic is at preventing bacterial growth and how fast it can move through the agar. However, several other factors can affect the outcome of these tests and lead to incorrect results. Antibiotic QC, why are my zones small? There are various factors affecting the zone of inhibition, resulting in small zone sizes. Here I will discuss few of them with suggested actions. Too heavy inoculum or error in inoculum. When too heavy inoculum or error in inoculum, inhibition zone will be smaller and susceptible strains may falsely reported as resistant. Repeat using McFarland 0.5 turbidity standard. Check expiration date and proper storage. Depth of medium to thick. When depth of medium to thick more than 4 mm, rate of diffusion of antibiotic will slow and smaller zone. Use agar with depth approximately 4 mm. Recheck alternative lots of MHA. Measurement or transcription error. Recheck reading for measurement or transcription error. Contamination. Major zone age with visible growth and detected with unaided eye. Use of magnification to read zones. Subculture to determine purity and repeat if necessary. Potency of drug reduced. Check QC of disc. Time of disc application longer than standard time. If plates after inoculation left at room temperature for longer, multiplication of inoculum may occur and small zones may be formed. Check time of this application. Acceptable within 15 minutes of plate inoculation. Temperature and time of incubation is raised, which results in small zone size. Acceptable 16 to 18 hours at 35 to 37 centigrade. Antimicrobial agent is degrading. Beta-lactam combination agent, single beta-lactam agent and the combination beta-lactam agent. Use alternative lot of materials. Check storage and package integrity. pH of media too high. When pH of media too high, penicillins, tetracyclines zones are too small. Acceptable pH of media range between 7.2 and 7.4. pH of media too low. When pH of media too low, aminoglycosides, quinones, clindamycin, macrolides zone sizes are too small. Acceptable pH of media range between 7.2 and 7.4. Calcium and magnesium content too high. When calcium and magnesium content too high, aminoglycosides and tetracyclines zones sizes are too small. Use alternative lot of media. Summary and conclusion. Thank you everyone for listening my presentation. Bismillahirrahmanirrahim. Assalamu alaikum everyone. My name is Dr. Fareen Sheikh, third year resident microbiology at Ziauddin University Hospital. It is an honor and privilege for me to present my topic in front of all respectable teachers, seniors and colleagues.
Assalamu alaikum. My name is Dr. Nida Ashraf. I am working as R3 resident. Assalamu alaikum. My name is Dr. Nida Ashraf. I am working as R3 resident at SIUT. My topic of microbooster presentation is how many discs on agar plate and why. Antimicrobial susceptibility is a fundamental mission of the clinical microbiology laboratory. It provides in vitro measure of the bacterial response to an antimicrobial agent, and it can be determined by various methods including the disc diffusion test, E-test, agar dilution, broad dilution and automated system. Disc diffusion test. In a disc diffusion test, a standardized suspension of the organism is buffered over the entire surface of the medium, and filter paper impregnated discs with a specific amount of the antibiotics are placed on the surface. After the overnight incubation, the diameter of the zone of inhibition is measured around each disc and qualitatively analyzed. The rate of diffusion through the agar is not as rapid as the rate of diffusion or extraction of the antimicrobial agent out of the filter paper discs. As a result, a logarithmic reduction in the concentration occurs as the distance from the disc increases. This will result in formation of clear zone sizes if the plate is previously being inoculated with the antimicrobial suspension. How many antibiotic discs should be placed on the culture plate? As per CLSI guidelines for the disc diffusion test, test a maximum of 12 discs on 150 mm plate and no more than 6 discs on 100 mm plate. Discs should be placed no less than 24 mm apart from center to center. This should be considered for Enterobacterales, Pseudomonas, Acinetobacter, Stenotrophomonas. The same guidelines are followed for Staphylococcus, Enterococcus, for Haemophilus influenza, Streptococcus pneumonia, Streptococcus species. Test a maximum of 9 discs on 150 mm plate and 4 discs on 100 mm plate. For Neisseria meningitis, 5 discs on 150 mm plate and 2 discs on 100 millimeter plate. For Neisseria gonorrhea, 9 discs on 150 mm and 4 discs on 100 mm. For some agents, for some antimicrobial agent, it could be 2 to 3 discs per plate. Why? Because these measurement or this placement is in accordance with the diameter of the are in accordance with the radius of the plate and considering the zone sizes which could be formed against these microbial agents. Improper placement of the disc will result in difficulty in measuring the zone sizes due to overlapping of the zone extended beyond the margins. Oval and elliptical zone will occur. Some organisms have unique properties like swarming by the proteus, hemolysis, and various other, and some will form discrete growth, and all these factors will cause enhance the difficulty in reading the correct zone sizes. Thank you. Assalamu alaikum. My name is Dr. Nida Ashraf. I am working as R3 resident at SIUT. My topic of microbooster presentation is how many discs on agar plate and why. Antimicrobial susceptibility is a fundamental mission of
Assalamu alaikum. I am Dr. Abdul from the Institute of Pathology, and I will be briefly discussing about borderline serology results. Borderline or equivocal serological results are inconclusive, lying just at or around the diagnostic threshold value, and they cannot be interpreted as either positive or negative as they are below the limit of detection. There can be multiple causes for borderline serology, and I have outlined the more important ones. First is the timing at which the sample was obtained. If the sample is obtained too early in the course of disease, there is a chance that the antibody titers may not be enough to cross the diagnostic threshold. Second is possibility of presence of preformed cross-reacting antibodies, that if the patient, for example, was infected to some related organism, and like in the case of COVID, if patient had recent infection with cold viruses, or for dengue serology, patient had recent infection with some other flaviviruses, their antibodies might cross-react and give a borderline positive result. And third is possibility of any type of pre-analytical or analytical errors. They are significant while we are diagnosing for viral infections, especially in their early courses, and for bacterial infections for which there is no easily available nucleic acid-based test or culture-based test available, like chlamydia, leptospira, mycoplasma infections, and in syphilis, for which serological tests are the gold standard, and also in Lyme disease. So now we come to the most important question: what should be our line of action, and what should we convey to the patients about their test results? So there is no single unanimous answer for all the different scenarios, or a single unanimous answer that can be applicable for all is that we should go for further testing in all of the borderline cases. And what type of further testing we should do, that again depends on our current scenario, that why we did the serological test in the first place. If there is a need for a prompt decision making, either for initiation of treatment or other purposes, then we should opt for a more specific or sensitive test for our next test, whenever it is available, like PCR or antigen-based detection test. If we only did the serological test for immune status checking or for epidemiological purposes, then there is no need for more specific tests, and we can repeat the serology in 2 weeks and compare the 8 sera. And finally, I have included an example of Mycoplasma pneumonia IgM levels that are falling in the borderline zone, 23.4 units per ml lies in the borderline zone. So as the PCR-based tests for Mycoplasma pneumonia are not widespread, so if they are not available, a clinical diagnosis can be made for initiation of treatment, and a repeat serology can be done after 2 weeks, and a 4-fold rise in IgG levels or a seroconversion from IgM to IgG can be taken as an evidence of recent infection. So that is all from my side, and thank you. Assalamu alaikum. I am Dr. Abdul from the Institute of Pathology.
So let's continue with our 3 case presentations. So I'll invite first Dr. Moiz Khan for presentation of his case.
MK वाली. Okay, so I'm Dr. Moiz Khan, a Year 5 resident from Aga Khan University, and today I would be presenting on a unique presentation of a rare syndrome. Okay, so I have no conflicts of interest to disclose. So starting off with the case presentation, so this was a 40 years old patient presented in the emergency department with complaints of low-grade fever, cough, weight loss, and a left thigh swelling since 1 month and altered mental status since 1 week. So he had a history of recurrent pulmonary tuberculosis in 2014, 2020, and 2021, for which he had completed full course of ATT each time. So the physical examination showed a pale, sick-looking and drowsy patient with a subcutaneous swelling in the left thigh that measured about 2 into 2 centimeters. So a complete blood picture showed a hemoglobin of 9.9, which was less, and TLC was 11.2 into 10 to the power of 9 per liter, with a critically low lymphocyte count, 1.3%, which indicated lymphocytopenia. So there was the ESR was raised, CRP was raised, and the procalcitonin was also raised. And blood CSF samples of the patient were sent for culture. After an ultrasound-guided drainage of the thigh swelling, pus was also sent for culture. So all of these cultures came out positive. First was the CSF culture, later blood and pus cultures also came positive. So HIV test was negative. I would be talking about the cultures a slide later. HIV test was negative. However, CD4 cell count was critically low, 38 cells per microliter, indicating severe immunodeficiency. So after other causes of CD4 deficiency were ruled out, hematological malignancy, chemotherapy-related, and immunosuppressive medications, these causes were ruled out of CD4 deficiency. So moving on to the culture plates first. So then I would be talking about a diagnosis. So this was the gram stain smear from the blood culture bottle, which typically showed rounded budding yeast cells, which were gram positive and encapsulated, which showed a clear halo around them. This was India ink of the CSF, and in this also you can see that typically rounded budding yeast cells with a clear halo. So these are the pictures of the culture plates, chocolate, STS abroad agar, and bismuth glycine glucose yeast agar, which is a biggie agar. And we can see the typically white to creamish colonies on STA and mucoid colonies on the biggie agar. So the organism was diagnosed as Cryptococcus neoformans on the Vitek2 yeast identification system, and susceptibilities were performed by broad microdilution method using the calorimetric microdilution panel, that is the sensititer yeast 1. So the MICs for fluconazole, itraconazole, and voriconazole and amphotericin B were 4, 0.06, 0.06, and 0.12 micrograms per ml respectively. The patient was started on the combination of amphotericin B and fluconazole. However, he expired after 1.5 months of treatment. So, a very severe opportunistic infection in this patient with a critically low CD4 cell count, with no prior known immunosuppression and HIV negative. So, what was the reason of low CD4 cell count? So, idiopathic CD4 T cell lymphocytopenia, ICL, is a rare and heterogeneous clinical syndrome that is defined by persistent CD4 T cell lymphocytopenia in the absence of infection with HIV or any other cause of immunodeficiency. So the mandatory criteria being a low number of CD4 cell count on 2 or more measurements over at least past 6 weeks, and laboratory evidence of a lack of HIV infections and absence of any alternate explanation as well. Alternate explanation as well. So it usually presents in the 4th decade of life with no gender predilection. So majority of the case reports and case series which I have searched have showed these findings, but more recently over the past 5 years, centers have been reporting a lower age group of presentation, usually in the 20th age group, 20 years age group, the 2nd decade of life. So usually a profound and persistent CD4 T cell defect predisposes to severe opportunistic infection, which leads to the detection of ICL in a person without known immunodeficiency. So no immunosuppression, the patient presents with a very severe opportunistic infection, and then this condition gets diagnosed later on. So various opportunistic infections have been reported in ICL patients in the past, including infections caused by Candida species, Cryptococcus neoformans, Aspergillus species, Histoplasma species, Blastomyces species, and Pneumocystis jirovecii. So I have done a thorough literature review over the past 25 years, and these are all the case reports of opportunistic infections in ICL patients since 1993, since it was first recognized. So you can see a myriad of organisms, a variety of organisms, from bacteria to parasite to the protozoan leishmaniasis. All of these have been previously reported in the literature. So in conclusion, we report a disseminated cryptococcal infection in an ICL patient, which is a rare condition. Prognosis has been reported to be very poor as a result of very severe opportunistic infections. And as knowledge regarding opportunistic infections in ICL patients is limited, hence our case provide useful insights regarding the opportunistic infection and the severity related to this disease entity. So this is the most severe case which I have come across in all the literature. So, so this was the case. So thank you so much.
So our second case will be presented by Dr. Aska. Can you please come?
Assalamu alaikum and a very warm good morning to everyone. I, Dr. Aska Zulfikar from Army Medical College, is going to present an interesting clinical case of an unusual pathogen we investigated in our lab. Once considered as a docile organism living peacefully with its usefulness in the food industry, this benign yeast has metamorphosed itself into a deadly beast. 6 months back, this 40-year male pigeon fancier reported to emergency department of our hospital with the presenting complaint of headache, altered sensorium, vomiting, photophobia from last 2 days. He had a history of weight loss and generalized weakness from last 2 months. On general physical examination, he was toxic looking, not oriented in time, place, and person. Neurological examination revealed sign of focal neurological deficit. Baseline investigation showed neutrophilic leukocytosis. Chest X-ray was unremarkable. His contrast-enhanced MRI brain and lumbar puncture were performed. CSF was sent to laboratory. He was shifted to intensive care unit due to his deteriorating condition. His contrast-enhanced MRI brain showed 2 rare neurological manifestations, that is leptomeningitis and bilateral basal ganglia infarct with cryptogoma formation. CSF routine examination showed raised white blood cell count and protein with decreased glucose. On gram stain, yeast cells were appreciated. A yeast-like structure with a clear halo around was appreciated on India ink stain, substantiating the presence of Cryptococcus-like fungus. In addition to blood and chocolate agar, CSF was inoculated on sobrad agar as well, which after 48 hours of incubation yielded small mucoid and shiny colonies. Gram stain of colonies showed narrow budding yeast cells. Cryptococcus laurenti was isolated and identified using the yeast identification system API 20C-OX, which was further validated with 85% probability by Vitek2 compact system. MICs were performed using the Vitek2 compact system, and the isolate was found to be sensitive to fluconazole, voriconazole, caspofungin, micafungin, amphotericin B, and flucytosine. As Cryptococcus usually infect hosts with diminished immunity, its isolation in this patient led to further diagnostic test. He was found to be infected with HIV, with CD4 count of 80 cells per millimeter cube and HIV RNA copies of 10,070 per ml. On the basis of clinical history, microbiological examination, final identification of Cryptococcus laurenti meningitis was made. Antifungal treatment with liposomal amphotericin B and fluconazole was started. Tuberculosis were ruled out to avoid immune reconstitution inflammatory syndrome due to low CD4 count. Cotimoxazole was also started prophylactically. Unfortunately, patient could not survive. Now moving on to a quick literature review. Cryptococcus laurenti, a fungus never been reported from Pakistan, that too from other parts of the world, mentioned in case reports only, that too from other parts of the world. Till date, 37 cases of Cryptococcus laurenti have been isolated in humans worldwide, with 14 cases from USA, Italy, Slovakia, and India. This fungus has thought to be found in soil contaminated with pigeon guano and transmitted to humans primarily through desiccated yeast cells from the environment. As per case reports, this rare pathogen has clinical diversity, mostly causing meningitis, fungemia, and cutaneous infections. We report the 4th case of Cryptococcus laurenti meningitis in an AIDS patient from the world and first from Pakistan. These antifungals and their combinations had remained the treatment options for most of the reported cases, although there is no validated treatment for Cryptococcus laurenti. Prompt removal of source is well documented for removing fungemia and preventing complication. Few strains of this rare pathogen has shown amphotericin B and fluconazole resistance in vitro. In most of the reported cases, the outcome was good, but only 2 cases reported fatal outcome, including ours, which was probably due to a very advanced stage of our patient. We conclude this rare pathogen with a rare opportunistic pathogen. To our knowledge, this is the first ever case reported in Pakistan whose isolation is more of epidemiological and academic interest, with treatment options not being different from Cryptococcus neoformans. However, with low mortality as reported, we can say that it has a better outcome for our patient with timely and targeted treatment. These are few of the references which I used. Thank you for your time.
So thank you, Aska, for this good case presentation. Now our last case is from Dr. Reja.
Assalamu alaikum everyone. I am Dr. Reja Zehra from Khan Microbiology resident, year 2. Can my presentation be? Display. Okay, so today the topic of my presentation is conventional pathogen in a not so conventional host. I have no conflict of interest to declare. So a 42-year-old female came to ER with diarrhea and vomiting for 4 days. She was diagnosed case of celiac disease with positive results for HLA DQ2 and DQ8. She was vitally stable. On examination, she was dehydrated, her abdomen was soft and non-tender. Rest of the findings were all unremarkable. So her investigation showed electrolytes on the lower side of normal ranges, and CBC showed hypochromic microcytic anemia, which is normal in a celiac disease patient, and HIV profile was negative. So over here, we need to consider the infectious causes of diarrhea. We can divide it into viruses, bacteria, protozoas, and fungi. Viruses include rotavirus, norovirus. Bacteria include E. coli, Campylobacter, Shigella, Salmonella. Protozoa include all Giardia, all the coccidias, and fungi include all Candida albicans and Histoplasmosis, etc. So a stool examination was performed which showed 6 pus cells and non-refractile, spherical to oval, slightly wrinkled bodies, as you can see in the picture. Stool culture was not performed. Pointer is not working. Stool culture was not performed. Okay, good. Okay, as you can see in the picture over here. Okay, so moving on, we performed a partial acid-fast stain which showed oocyst measuring 8 to 10 micrometer in diameter containing 2 sporocysts. Over here we can see it measured 8 to 10 micrometer in diameter. So moving on, the differential diagnosis. So the differential to be considered on partial acid-fast stain include microsporidia, which is 1 to 2 micrometer in diameter, cryptosporidium, which is 4 to 6 micrometer in diameter, Psychrospora catenansis, which is 8 to 10 micrometer in diameter, Isospora, which is 20 to 30 micrometer in diameter, and Sarcocystis, which is 6 to 40 micrometer in diameter. As pointed out my teachers, micro is the smallest, and then we can go alphabetically forward. Microspora is most commonly found in immunocompromised or HIV patients, and Sarcocystis is not common in Pakistan. So our differentials is narrowed down to only crypto, cyclo, and isospora. Isospora cyst is elliptical in shape, while we are left with crypto and cyclospora. So on the basis of size, we diagnosed it as cyclospora. So what are the other available identification methods? We already did wet mount. We can do different stains, which include Ziehl-Neelsen stain, Jensen stain, safranin stain, autofluorescence stain. Flow cytometry can be done. Molecular methods can be used for the diagnosis, and histopathology of duodenal biopsy can also be done. So this is the life cycle of cyclospora. Basically what happens that oocyst is released in the feces, it goes into the environment, it sporulates, and then we re-ingest it. Over here, sexual and asexual life cycle takes place, and then oocyst is released again in the environment. So spectrum of the disease. Several studies have reported diarrhea in immunocompetent patients as well. According to the study, travelers from Latin America, Indian subcontinent, and South Asia had 96% travelers' diarrhea due to cyclospora. Infections are more severe in immunocompromised patients. The main symptom is intestinal symptom, which includes severe watery diarrhea. So what actually happens to gut mucosa in celiac disease is undigested gliding segments come. They bind to CXCR3 receptors on antigen-presenting cells. It increases zonulin. Zonulin in turn increases intracellular and paracellular permeability, which leads to the entrance of these gliding fragments into the lamina propria. Activation of DQ2 and DQ8 restricted T cells takes place, which leads to activation of innate immune system, activation of adaptive immune system, and it leads to autoimmune insult of the gut mucosa. So now linking this, This is the diagrammatic explanation of what I just explained. Gliding peptides come, it binds to antigen presenting cells, HLA DQ2, DQ8 restricted T cells get activated and insult to the gut mucosa takes place. अब हमारे पेशेंट में क्या हुआ, possible mechanism of coccidian infection in a celiac disease is proposed by Lakshman et al. And they say that gliadin polyQ P422 matching sequences are found in coccidian protein, which may facilitate parasite invasion in the lamina propria by binding to CXCR3 chemokine receptor. This is normal intestine. Over here, coccidia come, polyQ sequence bind to CXCR3. These red balls are zonulin. They increase the intracellular spaces, and coccidia can invade and cause diarrhea in a celiac disease patient. So I did a literature search and I found some evidence from Pakistan. This paper was published in Armed Forces Journal. This is a case report. There are several studies which states that coccidian infection can actually take place in immune-mediated intestinal conditions, which include celiac disease. So what is the treatment of this? We do symptomatic treatment. Drug of choice is trimethoprim, sulfametazole, and patients who are allergic to sulfonamides can be given ciprofloxacin. So our patient was given trimethoprim 960 milligrams BD for 7 days and was discharged home in a stable condition. So the conclusion is this was a symptomatic Cyclospora catenacensis infection in a celiac disease patient. These were the references which I used. Thank you so much.
So for we can ask 1 or 2 questions with our clinical case presenters. So I will like to ask 1 question from Aska. Aska, can you please stand up? So I was wondering whether if you are going to report this as a first case of Cryptococcus lawrentii infection. So I will strongly suggest that if you have the isolate, you go for molecular identification, because any good journal will require it to be confirmed. So do you have the isolate with you? Okay, so please do that. So other questions? Any questions from Moiz? अच्छा, आप लोगों ने सब हाँ, thank you, submit. Yeah. Okay, good. So questions from Moiz, questions from Rija. Chale. So I don't think.
One finding was common in both cases of the Cryptococcus neoformans.
So
amphotericin B and fluconazole, and both patients died.
Yeah. They were quite critical.
I think both antifungal may not be a good thing for that patient.
No, actually, हाँ. No, हम ये नहीं conclude कर सकते हैं, Dr. Azhar. Probably those were very sick patients, and initially the patient that Moiz presented, initially the patient responded and was sent back home. But this was at, I think, 30 days follow-up when Moiz आप भी बता दें. अच्छा.
I have another query.
अच्छा.
Probably I missed that. Moiz, in your case, did you perform HLA typing of that patient? Because that disease was HLA type related. Okay, so there was idiopathic case of this lymphopenia. No? So I want to know what that was the criteria, diagnostic criteria was given, but did you correlate that with the HLA typing, or do you have plan in future to do that?
Yes, actually we have plan in future to do that. In clinical cases, as I mentioned, that when an opportunistic infection presents, the first gut response is to do HIV. So first you rule out HIV, then you ruled out other causes, medication-related CD4 cell lymphocytopenia, and after these hematological malignancies, and 4-5 types of entities have been ruled out. So a diagnosis of idiopathic CD4 lymphocytopenia is made. But we have a plan to actually explore this in future.
Moisa, have you found in literature what is the treatment duration for this disseminated cryptococcal infection? Is there any?
So there is no specific treatment duration, a different treatment duration as related to common cases, conventional cases of Cryptococcus neoformans. There is no specific guidelines. The CD4 lymphocytopenia, as seen in HIV, the prophylaxis which is advised by the guidelines is the same that has been used, exactly, same has been used in the cases and the series which I have reviewed.
So if there are no further questions, so I'll request Dr. Muniba and Dr. Fiza to start their session. Just another thing that I wanted to point out, that 2 fungal cases were not selected because I like fungi. This was this was because like most of the cases that we got were related to fungi. I don't know because why is that, but we need to identify more and more viral infections as well as other infections. That is probably due to the limited capacity to diagnose those sort of infections.
Presentation. So, Assalamu alaikum everyone.
Assalamu alaikum. I'm Dr. Muniba Hassan Saeed, Assistant Professor Infectious Diseases at Dow University, and with me is Dr. Fiza Farooqi,
Assistant Professor Microbiology at an Infectious Disease Hospital and Research Center. So we've been taking you around the world since the last few conferences. This time we'll be taking you inside a microbiology lab. This is not a very technically accurate microbiology lab, so forgive us if there are some, there's no anteroom with the microbacteriology unit and all. So please, let's ignore that. EA control.
Okay. So this is a quiz, and you need to log in. You have to click, you have to take out your cell phones, go to the site joinmyquiz.com and enter the quiz code.
It is at the bottom of the slide. You can see a 447627 is the quiz code. Joinmyquiz.com.
No.
Chrome pe, your browser.
Browser. Join. मेरा तो हो रहा है.
We have some people who have joined, so please just check your connections once again. 5 people have joined so far.
Turn on your mobile data. I think it's open on my cell phone.
PC guest पे देखना.
PC guest.
Joinmyquiz.com. We have 11 people now. It's a simple quiz, maybe a few complicated questions, but a lot of them have been answered in the previous sessions also. So I'm hoping that if everyone listened, they will be able to answer the questions. 447627. Reload करें. आपका Wi-Fi connected है. Data on.
Data ही on कर लेना.
Data on है. हाँ बस data से हो जाएगा. Joinmyquiz.com खाली बगैर www. 13 questions and a few sub-questions in some of them. Easy. Should be about half an hour. Some questions have very small time limit, 10 seconds ka bhi hai. Bahut simple hai wo. And then there are some that are more difficult, so 45 seconds tak ka time hai. So it's variable, depending on the severity of difficulty. So we have 24 participants so far. वो वाली दिखा दे वापस. इस पे कोड आ रहा है.
आ रहा है.
अच्छा आ गया. When should we start?
देखना. All set?
Has everyone over here joined? No? Oh. So, if you can turn off your Wi-Fi, then the data works better. Yeah, turn off the Wi-Fi. If you have your data plan activated. Because the Wi-Fi is lousy so far. Oh. Name किसने नहीं किया? अब पता नहीं. So I think we can start after 2 minutes, right? 2 minute बात करते हैं. At 12:20. हो गया कर दे? Dr. Muniba? At 1 minute. Okay. Achha, I'm starting now. So we went inside a microbiology laboratory. We were invited to a lab, and there's no name of the institute or the lab. We went inside the microbiology laboratory, and the first place where we were called was the processing and receiving area. Oh, yeah, a few urine samples were brought to the lab for processing. The question is, will you accept or reject these specimens based on what we tell you? So you'll have to answer separately for each specimen, and there's a short time for answering these questions because they're simpler. आ रहा है, अब आएगा. Oh. एक second. हाँ, क्योंकि हमने quiz नहीं start किया, अभी question नहीं आया. Okay.
The quiz.
So this is the first question. A culture collected through a condom catheter. Will you accept it? ये कर दे control अब इधर आ जा. मैं ये कर रही हूँ. Time इन वाले questions के लिए कम है. These are simple questions.
Next. Urine collected from an percutaneous nephrostomy tube. Will you accept or reject? 10 seconds. Time's up. Urine sample brought in a leaking container. Will you accept or reject?
अभी हाँ मैं कर रही हूँ. हो गया. वो 3 सेकंड लेता है स्टार्ट होने में.
Delay अभी.
आंसर इसके बाद बता देंगे. थोड़े मुश्किल जब आएंगे तो हम एक्सप्लेनेशन भी दे देंगे. कर दो नेक्स्ट क्वेश्चन.
Next, urine culture with 2 labels of different patients. Accept or reject? Time's up.
ये सही वाला है, इसको रोक दूँ.
Yes.
So we now went to the microscopy unit. What?
Unable to save your response.
इसको रोक कैसे सकती हूँ मैं?
Okay, moving
हाँ,
on to
हमारा
our next question. A child had pharyngitis. On examination, there was a whitish membrane on his pharynx and tonsils. A nasopharyngeal swab was sent to the lab. There was the club-shaped gram-positive rods on the gram stain. What is the next test you should perform? Is it the Celiac culture, Albert stain, or API?
Quickest is the keyword over here. थोड़ा सा हमने इसमें synchronize गलत हो गया. हाँ. ये इसमें सबने आंसर अगर नहीं किया तो we can restart this also.
Restart कर.
इसको restart कर दूँ?
Okay.
वो नहीं, वो थोड़ा सा syncing में मसला हो गया.
Okay. So you can respond now. The quickest test.
इस क्वेश्चन को हमने फिर स्टार्ट कर दिया फॉर दोज हु हैव नॉट आंसर्ड अभी भी कुछ लोग रह गए हो गया ओके
And from the big, we were moved to the culture bench. And here we had a 35 years old female who presented with complaints of burning micturition and visited her doctor who had a culture done to check for UTI. This is the culture report. It's an E. coli which is sensitive to all except ampicillin. Patient was treated and her urine cultures were repeated. At this time, she did not have any urinary tract symptoms. And the culture report shows E. coli, which is a resistant bug. What would you do? You'll treat with nitrofurantoin, fosfomycin, no treatment, or amikacin.
So अब इस बार इसका explanation थोड़ा छोटा सा देना
So the answer is no treatment because the patient was asymptomatic.
Okay. Moving on to the next bench. We were called back to receiving and processing area because this time around there was a brain abscess sample. How will you process this sample according to the most correct reference? Tell me. So these are your options. Would you perform a gram stain and inoculate into chocolate agar, blood agar, and McConkey? There are several places that we've mentioned. So gram stain, chocolate, blood, McConkey, and colistin nalidixic acid. Gram stain, chocolate, blood agar, McConkey agar, colistin nalidixic acid, and anaerobic culture. Or a gram stain, chocolate agar, McConkey agar, and anaerobic culture. So try to recall the reference guidelines that we have.
Answers may be shuffled when you see it on
Yeah,
your
the
cell
answers
phone.
may not be in the same sequence.
So
Option
the,
R or
choose the option which is the appropriate in your cell phone.
yeah, so the ABCD over here is not probably the ABCD of your phone.
Time's up. So the correct answer is
The longest option was the correct answer. So you need anaerobic culture and nalidixic acid and blood and McConkey and everything. Acha. Moving on. Back to bacteriology. Chalo, pehle question chala de.
The question is of a young female with a history of IV drug abuse, presented with severe headache, fever, neck stiffness, and photosensitivity. After baseline investigation, a lumbar puncture was done. Microscopy revealed the following picture. This is the microscopy.
So everyone should now recognize it, even if you're not from microbiology. Okay. The question, though, is how will you perform AST of the most likely organism that you can identify from the picture? Kaun bola?
Disqualify. Shuffle है.
Website पे shuffle on.
6 seconds left. Okay, time's up, and the answer is?
Broth microdilution, as was already announced, and most of you probably already know. We've had 2 presentations on crypto today. Sorry?
We then moved to the
serology
bench. Okay.
हम दोनों साथ चल रहे हैं. वो रोटेट कर रही है माइक्रो.
A young boy with high-grade fever was brought to clinic. He tested positive for a blood parasite. On microscopy, slightly enlarged red blood cells were seen with amoeboid rings. Trophozoites showed amoeboid cytoplasm and large chromatin dots. Identify the parasite. Very simple question. Is it Falciparum, Babesia, ovale, vivax?
We took parasite pictures from DPDX so that, you know, wherever you've learned from, you can recall the pictures. मुश्किल तस्वीरें नहीं उठाई हैं. Also think of the common parasites.
So the answer is?
Vivax, yes.
Yes. No, vivax. And then
moving on to mycology.
Dr. Koss's favorite bench. So a known case of invasive ductal carcinoma undergoing chemotherapy has now presented with hemoptysis. Her lung biopsy was sent for investigation. Aspergillus flavus grew on culture. Histopathology report was negative for malignancy but showed hyphal elements with associated tissue damage. Which type of fungal disease can this be categorized as?
So revise your EORTC MSG criteria. Is it proven, possible, probable, or no fungal disease? Easy है मगर ये question.
But half of them didn't answer. Very easy question.
This was a very easy question. There is growth of fungus and there is associated tissue damage shown in histopathology. So this is a proven invasive fungal disease. चले. Mycology से हम गए media room और QC.
और इस टाइम हम बेंच पे खड़े हो गए. बैठने का टाइम नहीं मिला. Next, the disc diffusion QC abnormality with its cause.
So if you were looking at the micro booster presentations earlier, you should be able to. Chale? Next question. Okay. So, the Pseudomonas aeruginosa ETCC 27853 zone against amikacin was too small. What do you think is the correct answer? Chale? Is the pH too low or too high, or does the agar have too much or too little of calcium magnesium? Let's answer together. Oh my god. मुझे याद ही नहीं. थोड़ी बात मुझे बताएं. हाँ? याद है? किसने किया था present ये?
ये ज़ियाउद्दीन की थी. नहीं. So the answer is C.
चले बताएं.
C.
The calcium magnesium content when it's too high, the calcium magnesium. चले next.
Next is.
वैसे हाँ. सही चलो maybe we should have removed that option then. But जो CLSI का जो table था ना उसमें इसका relation उसके साथ pseudo के लिए directly नहीं दिया हुआ था. लेकिन दोनों जवाब गलती से सही हो सकते हैं. हाँ. तो चलो.
Next.
The Staph aureus ATCC 25923 zone was too small for clindamycin, and again the same options this time. इसमें आ रहा है जवान से बात है.
ओहो ज़्यादा गलत वाली म्यूजिक आ गई.
अभी आएगा लीडर वर्ड. क्या है आंसर?
pH of media too low.
क्लिंडामाइसिन का ये जो टेबल अभी दिखाया भी था, इनफैक्ट उसने मैं भूल गई वो ज़ियाउद्दीन की प्रेजेंटेशन थी उसमें ये टेबल में था भी.
SIUT की थी.
SIUT थी. हाँ वही मैं देख रही हूँ. उस वक्त स्किप कर गए होंगे. चले नेक्स्ट क्वेश्चन. मैं आप करें पहले. अच्छा. E. coli ATCC imipenem zone was initially acceptable, but over time it has decreased to be out of range. What do you think is the reason? Is it too high or too low pH, degrading antimicrobial agent, or calcium magnesium content too low? छोटा होता जा रहा है. हाँ. ये तो टेंशन वाली इसकी म्यूजिक है ना.
अरे गलत हो गया फिर.
ये किसी के वो ना बहुत लाउड है जिसका गलत होता है. We have one clear winner वैसे so far. But tough competition. So the answer is antimicrobial agent degrading. इमीपेनम तो हम सभी फेस करते ही रहते हैं. बाहर ना रह जाइए, ना हो जाए, ना हो जाए. चलिए नेक्स्ट. So हमारा QC वाला काम हो गया है. We were called back into bacteriology. और अब हमने क्या मसला देखा यहाँ पे? सवाल, मसला नहीं, केस. So sensitivity patterns हैं कुछ हमारे पास, and you'll have to identify which gene is responsible for those patterns. So एक इसको कुछ आसान भी, इसमें कुछ थोड़ा सा सोचने वाले भी हैं. So we have given you 20 seconds for each question. चलिए. First one.
First one, which gene is responsible for this effect in Staph aureus?
So हम आसान
बहुत
शुरू
very
करें.
simple, very simple. What's the picture showing? It's a D test.
कौन है जिसका गलत हो रहा है? भाई क्या है आंसर इसका?
gene
mutation.
हाँ, सही. All right.
चलिए next question.
Next.
So again Staph aureus है आपके पास, और ये वाइट टेक ने शुरू में दिया है आपको लिखे हुए cefoxitin स्ट्रीम पॉजिटिव. इसके लिए कौन सी जीन रिस्पॉन्सिबल है?
उफ, एक साथ सबने करके आंसर कर रहे हैं. एक साथ झट.
ऑप्शंस क्या दिए हमने? अच्छा ये रही. इसको म्यूट कर दूं?
नहीं.
अच्छा चलो.
And the answer is MAC gene. Very good.
चलिए.
Now, which gene is responsible for the shown phenomena in KP?
So do you recognize the test? M से और E से लगा हुआ है, ठीक है? So चलिए. नहीं पिछला पिछला पीछे.
This is a bit tricky. ID के भी सही.
नहीं ये एक ही है. एक डिस्क को 1 घंटा रखा हुआ था, एक डिस्क को 2 घंटा, एक को 4 में DDT है. नहीं ना वो है. हाँ लगा सकते थे. बात तो सही है. नहीं ये तो उठाई तो हमने गूगल से. एक हाँ नहीं सही बात है.
ये हमारी थोड़ी एडवांस लैब है.
हमने कर लिया. हम क्रॉप कर देंगे. 4 घंटे वाले खाली नजर आ रहा हूँ. हाँ ये हम कर सकते थे.
ठीक.
तस्वीर क्रॉप कर सकते थे. क्या है आंसर? क्या है भाई?
यस.
नहीं इधर पूछ रही हूँ.
अच्छा.
NDM है. क्यों? और जो EDTA है वो उसको डिग्रेड कर देता है मेटालोबीटा लैक्टेमेज को. ठीक है. मेरा पेपर था. मेरा आधा था, इसी में नहीं था मेरे में.
चलिए उसी के एक है.
अब हाँ नेक्स्ट क्वेश्चन रिलेटेड टू द सेम थिंग. दिस टाइम यू हैव नो जोन अराउंड द EDTA वाली डिस्क. अगर हम तेज चलाते ना तो ना फोकस कर पाते शायद. एक ही बचा. डिस्कशन कर लिया थोड़ा.
सही बात है.
ये आ गए आंसर्स.
So the answer is
KPC this time, serine metallo-beta lactamase. ठीक है. So the last one ये vanc resistant है. It's an enterococcus strain. अब चलो ये तो हमने आखिरी आसान बहुत दे दिया.
बहुत ही आसान है.
चला नहीं क्वेश्चन. सॉरी. जल्दी सब इसका जवाब दे दें. हाँ कर सकते थे.
Van A, Van B, Van C.
गया हमारा. Question 9 है ना, we have 13 questions, 4 रह गए बस. सही है.
कितनी सबके सही हो गई है, कैसी म्यूजिक है.
चलिए, let's move on to the next question quickly then. अब हम यहाँ से कहाँ गए हैं भाई? Microbiology चले गए हैं. और यहाँ पे a 23-year-old girl presented with fever, cough and weight loss since 2 months. Chest radiograph showed bilateral diffuse infiltrates. Sputum AFB smear was positive. Gene expert was negative. AFB culture was positive in 3 weeks, and after exposing the growth to light, the colonies look like this. So, what do you think is the organism? Google भाई थे. Google ने किए. तो अभी रेजिडेंट्स को याद होगी रंजन क्लासिफिकेशन. बड़े लोग भूल जाते हैं अमूमन. याद है? कल पढ़ाया है. क्या है आंसर? क्या है आंसर? कैंसेसियाई, राइट. येलो पिगमेंट भाई, फोटोक्रोमोजन है. चले, सो अब वापस हम बैक्टीरियोलॉजी में आ गए. And over here we had a gardener who presented with an ascending pattern of nodules on his forearm, and his biopsy was sent for histopathon culture. Gram stain में क्या नजर आया? Gram positive, weakly positive branching rods, and a partial acid-fast stain showed a picture which we'll show you in the next slide. Growth of chalky white colonies was observed after 2 days. बहुत सारा लोड था bacterial, तो जल्दी grow कर गया. And the question is, अभी sense ही नहीं हुई है, तो what antibiotics would you suggest until the report is finalized? मैंने खींची, ये मेरी अपनी पिक्चर है. So again, please follow your guidelines. नई नई बातें हम सब करते रहते हैं, लेकिन try to remember what was in your guidelines. नहीं कर सकते. स्किन है, इसकी वजह है, क्यूटेनियस है. क्या है जवाब?
Co-trimosol because it's cutaneous.
राइट, और अदरवाइज हेल्दी था हमारा गार्डनर जो था. अच्छा, अब हम वहीं घूम रहे हैं. ठीक है,
नहीं हम खुश भी हो गए.
हाँ, चलिए. अब क्या है? 30-year-old wrestler. चलिए यहाँ पढ़ लें.
30-year-old wrestler presented to ER with fever and swelling on hand since 10 days. Earlier during a fight, his hand was hurt. He has an abscess on his hand with foul-smelling discharge. On pus culture, pinpoint colonies are seen on blood agar. These are gram-negative rods, non-motile, catalase negative, and oxidase positive. What is the likely organism?
हाँ, मैंने चला दिया. लंबा क्वेश्चन था ना, तो थोड़ा लेट शुरू किया. So Aeromonas है, Erysipelotrix है, Eikenella है, Sphingomonas है, Aggregatibacter acetone.
Lost connection to quiz. एक मिनट.
नहीं, हमारा कनेक्शन लूज हो गया. 1 सेकंड भाई. पीछे, हाँ पिछला दिखा दे. आगे. सो नीचे जो आईडी दी हुई है वो थोड़ा सा किसी को याद हो अगर. उसके अलावा क्लिनिकल प्रेजेंटेशन भी थोड़ा सा सोच लें.
क्लिनिकल प्रेजेंटेशन वेरी इंपॉर्टेंट.
क्लिनिकल जो है, हाँ, वो भी थोड़ी डायरेक्टिव है और थोड़ा मुश्किल हो तो हमने माइक्रो भी दी हुई है. राइट, आवाज आना चाहिए. यहाँ बहुत लोगों ने आंसर भी कर दिया है. मैं रीस्टार्ट कर दूँ? रीस्टार्ट कर दूँ अगर नहीं आया है. पिछली स्लाइड दिखा दें.
क्या वो आया?
अब आया होगा. देखिए, रिफ्रेश कर देंगे.
नहीं, यही वाला दिखा रहे हैं अभी हम. मगर यहाँ 32 ने रिस्पॉन्ड कर दिया.
हाँ, ये 15 लोग जो हैं इनके पास नहीं आ रहे हैं. रिफ्रेश कर दें. कर दूँ यहाँ एंड कर दूँ, क्या पता नेक्स्ट आ जाए.
Some participants are here to answer. Do you want to?
कुछ दिन हो गए और देर में तस्वीर लिया. नहीं, बड़ी बुरी बुरी तस्वीरें थी गूगल पे लेके. बड़ी कॉलोनी सारी.
क्या करना? दोबारा रीस्टार्ट करके.
नहीं, फिर हम एंड कर लेंगे. नेक्स्ट करके एंड कर देती हूँ. एक सेकंड.
लिंक तंग.
सब है, मैं नेक्स्ट करके देखती हूँ इसको दोबारा.
अब आएगा शायद.
आ गया. चलो. वो डिस्कनेक्ट हुआ था ना बीच में, उसमें गया होगा. सब हमारा आखिरी है ना इसके बाद. दिस इज द सेकंड लास्ट क्वेश्चन बाय द वे. वी हैव ओनली वन मोर क्वेश्चन विद अ फ्यू पार्ट्स.
हमारी लैब में कल्चर प्लेट्स भी हैं.
हाँ, हमने
और
सजाई थोड़ी सी.
यूरिन सैंपल भी रखा है हमने.
नहीं, वो ब्रेन एब्सेस वाला है.
और उधर बॉटल भी रखी है.
चलो.
मीडिया रूम में.
नहीं, वो दिखा रही है, हमने सजावट की है थोड़ी.
अच्छा,
आई के नला था.
हाँ सॉरी. क्योंकि रेसलर है, उसको मुंह से लगा है, तो ओरल उससे.
क्लिनिकल ही वो वहीं से बता रहा था. फिर आगे जो सारी बायोकेमिकल आइडेंटिफिकेशन थी वो भी आइकिनेला वाली थी. सब पढ़ ले, जाके रिवाइज कर ले क्या क्या था. कैटलीज, ऑक्सीडेज, पता है. हाँ, इससे पहले जो हमने ली था इतनी बड़ी बड़ी कॉलोनीज थी. हाँ, सो कॉलोनी को और पिन पॉइंट कॉलोनीज पिन पॉइंट ही होती है. नहीं, चलिए बता दें क्या क्या. हाँ, मगर स्मेल हम इनकरेज नहीं करते ना. हाँ, पिट्स करता है, गड्ढे में होती हैं कॉलोनीज. बिल्कुल.
ग्रोथ इतनी ज्यादा नहीं होती है.
हाँ,
लेकिन इतनी रिच, इतनी ज्यादा अमूमन नहीं होती.
चलें नेक्स्ट कर लें. सो अब हम वापस माइक्रोस्कोपी पे आ गए हैं और वहाँ पे वी हैव सम स्लाइड्स जिसमें स्टूल के वहाँ से आई हैं पैरासाइटोलॉजी से. फिर उस साहब ने भेजी हैं. हमारी इस वाली लैब में आए हुए हैं आजकल. तो इनका सवाल है कि आइडेंटिफाई एंड देन रिकग्नाइज कि कॉलोनाइजर है या पैथोजन है. नेक्स्ट क्वेश्चन. एक सेकंड, अब साथ साथ चलेंगे. अपना व्हाट्सएप अगेन DPDX की उठाई हुई पिक्चर्स हैं, तो आप पढ़ाइयाँ करें अगर थोड़ा रेजिडेंट्स के लिए थोड़ा ज़्यादा डायरेक्टेड है. So you should remember.
उनको एक्सप्लेन करते हैं.
इसके अंदर 20 सेकंड्स दिया ना. हाँ. सो ये कौन है, किसी ने किया आइडेंटिफाई? एंडोलोमिक्स नैना है. इट इज़ अ कॉलोनाइजर. इट इज़ अ कॉलोनाइजर. ठीक है, छोटा सा होता है, ओवल टू सर्कुलर होता है एंड द साइटोप्लाज्म फिल्स इट. चलिए नेक्स्ट. होना चाहिए. हाँ, बुकिश पिक्चर है बिल्कुल. क्या है जवाब? और पैथोजन है ना? क्यों दिख रहा है हमें वो? चलिए नेक्स्ट. हाँ, इंजेस्टेड RBC नजर आ रहे हैं. चलिए नेक्स्ट क्वेश्चन. ये कौन है? ओह नहीं, अभी
नहीं, आंसर कर दें बस. कॉलोनाइजर और पैथोजन.
हो गया?
इसमें नजर क्या आ रहा है वो बताना.
जी बता देंगे, अभी हो तो जाए, अभी नहीं हुआ.
जो बाद में देखो वैसे भी हार ही जाएगा, उसमें टाइम ही हो गया।
खत्म, 1 सेकंड रह गया। क्या है ये? आयोडीमीबा है, ठीक है। ग्लाइकोजन वैक्यूल बहुत अच्छी सी नजर आ रही है। चलिए नेक्स्ट। ओह नेक्स्ट ये भी अच्छी तस्वीर है बहुत। हाँ ये रिपोर्ट कौन चल रही है भाई? टॉप पे वही चल रही है।
अरे मैंने
आई थिंक लास्ट टाइम भी वही जीती थी। सेम विनर है। अच्छी बात है, मजे की बात है। क्या है ये? वैलेंटिडियम कोलाई। कैसे पहचाना? सीलिएटेड उससे। कॉलोनाइजर है, पैथोजन है? पैथोजन है बिल्कुल। चलिए भाई नेक्स्ट। ओह नेक्स्ट, सॉरी मैंने यहाँ नहीं किया, सॉरी। साइज नहीं दिया मगर 8 to 10 कर ले माइक्रॉन्स। 8 to 10 माइक्रॉन्स है। आना चाहिए सबको, सबको जवाब देना चाहिए सही, सबको सही जवाब देना चाहिए। दिस इज द लास्ट क्वेश्चन भाई। थर्टीन है, 13 में पार्ट्स थे, 3 के सब पार्ट्स थे। So there's a total of 26 questions actually. Technically 13 years. So यही हम वापस जा रहे हैं। We are done with our quiz and we are done with our day in the lab. चलिए और भी जाएंगे, चलिए ओके। भाग के चले गए। सो रिजल्ट टाइम हम ये यहाँ पे डिस्प्ले नहीं कर सकते, लेकिन एक सेकंड, नेक्स्ट क्वेश्चन क्यों कह रहे हैं? यस
और
हमारे पास मुस्तकिल क्वेश्चन 1 है ना, एक ही है जो कि टॉप पे चल रहे हैं। लेट्स सी इफ शी वन और नॉट।
अब ऐसे बहुत क्लोज था, 2 के अंदर,
2 में था,
लेकिन फिर
लेकिन पॉइंट ये कि इसके अंदर बहुत बड़ी कनेक्टिविटी की भी है। फोन एंड देयर नेटवर्क। गुड जॉब।
पहले थर्ड बता।
थर्ड और सेकंड हम दे नहीं रहे ना।
हाँ, तो जो फर्स्ट है वो है डॉक्टर रबिया फ्रॉम AFIP। क्या बात है, वेरी गुड।
लास्ट टाइम भी जीती थी है रबिया?
नहीं, रबिया नहीं थी,
रबिया
दूसरी थी।
लास्ट टाइम आप नहीं थी। अच्छा अच्छा, AFIP का ही कोई था। चलिए कांग्रेचुलेशंस रबिया,
वेरी गुड।
तो हर सवाल का सबसे पहले सबसे सही जवाब।
हाँ, सेकंड बता दीजिए। टाइम टू पॉजिटिविटी इनका
बिल्कुल इनका अच्छा था। सो नेक्स्ट है हमारे पास नंबर 2 पे सैम फ्रॉम JMDC। एंड नंबर 3 पे है जी।
अच्छा वैसे
डॉक्टर जीशान।
लेकिन एक बात मैं बताऊं कि रबिया ने स्कोर किया 88%, सनम ने 84% और जी ने भी 84%।
चल,
और एक और भी है 4 जिसका 84% है, ट्रिपल M।
इससे दिल
हाँ
डिस्को। हाँ नहीं फिर उसके नहीं, मगर वैसे हमारा प्राइस एक ही है 1 के लिए। हम बता रहे हैं वैसे ही सेकंड और थर्ड खुश करने के लिए आप।
हाँ और
शायद आने में टाइम लगे प्राइस, ऐसा लग रहा है मुझे। अदरवाइज रिटर्न। हाँ बाद में ये उठा
कोई कुछ शायद है।
कुछ
ये फोन किसका है?
बिल्कुल नहीं।
चले ओके, so let's come to our the conclusion of this session, and I will like to invite Dr. Iram Khan. First, I think Dr. Meena to conclude, give concluding remarks regarding the session. Or Fareen aa jaye. हाँ.
Assalamu alaikum. It was an honor to be here. An amazing session. I think the bottom line is that how closely we are linked in ID and micro. And all the talks actually sort of highlighted how we need to break barriers and how we need to work together for infectious diseases in general. All the talks geared towards different topics, starting from a lot of things were very interesting for me from an ID point of view, as far as your breakpoints were concerned and so on, but really in particular, Dr. Rumina's talk and Zishan's talk. Amazing, very heartfelt and directed towards what is reality for us and what we need to, and what we are working with. I think it was amazing, and the case presentations were also very good, very difficult to judge between them, and very well presented. And as always, we've been seeing from MMITSP as well that our quiz is very, very well received. Thank you.
So I will now invite Dr. Eram to announce the winner for the posters and oral talks.
Okay, so Assalamu alaikum everyone, and amazing session, Kausar. Congratulations to you and the entire team. I think it was very well, very well thought through, very well planned, and was received very well, so well done. So we move on to the tha jiska intezar kind of a thing, right? So the criteria, the way we are going to announce is, first I'm going to announce the poster presentations, and then we will move on to the oral presentation. And one of the oral presentations will then be nominated for the Bukhari Award, because every discipline announces one. And then the way the Bukhari Award is, then they pool all the names together, and it's kind of a poll, and they pick one. So lucky draw ki tarah se hoga, so whoever gets it will be the one, okay? But every society nominates their one best oral presentation as the potential or nominated for Bukhari Awards. So starting without much await from poster presentation, the third award position in the poster presentation goes to Dr. Najia Ganchi. Her presentation, placental infection with Plasmodium vivax, P. falciparum causative agents of malaria and pregnancy outcomes from Pakistan. Dr. Najia Ganchi from Aga Khan University stands for third position for oral presentation. Najia is here. Sorry, poster. My apologies. This is for the poster presentation. The second for the poster presentation is improving hand hygiene through WHO self-assessment framework at the Kidney Center Postgraduate Training Institute. The award goes to Babar Ahmed. Babar is here. Oh, so Dr. Safia is here. So maybe just give it over to you, Safia, then. So I'll just announce first, and then we will give the presentations later. And the first position for the poster presentation goes to reporting mycetoma cases from skin and soft tissue biopsy over a period of 10 years, a single center report and literature review from Pakistan, goes to Dr. Mohammad Zishan, Aga Khan University. Well done, Zishan. So, So may I request the three, Dr. Najia is not here, but anyone who would like to take on her behalf. Imran, were you part? Yeah, maybe Imran can take from her. Ajay. So, third position first, and then. Thank you. Okay. Second position, Safia, on behalf of Babar. Thank you. Okay. And the first position, Dr. Mohammad Zishan. Thank you. And now we move on to our oral presentations. Yeah. So I've been told that for the oral presentations, we have one award here. So for the third, at the third position, actually I don't have the titles with me here for the oral ones, I'll just move them. So the third position goes to Arsalan Ahmed from Khan University. The second position goes to discordance between gene expert MTB RIF and conventional culture methods for diagnosis of extrapulmonary tuberculosis in smear negative presumptive tuberculosis patient. This goes to Dr. Quratul N. Zahid. Yeah, she's from Indus Hospital. Is she there? Okay. And the first position goes to pooling of the urine specimen for diagnosis of chlamydia trachomatis by PCR, Rifat Bushra. So with this, the kiska tha top? Okay, please announce.
So first prize, as we all know, goes to Dr. Rabia from AFIP.
So with this, I think we come to the conclusion of this session. Thank you, everyone. We will request you to now join the main hall for the closing ceremony. Thank you.